So now that we spent quite a bit of time diving into those crucial Dart and Flutter features, it's time to dive deeper into Flutter, and in this course section, we're going to explore how we can add more interactivity to our Flutter apps, how we can handle more than simple button clicks, and also how we can theme our Flutter apps to apply some global styling to our Flutter apps. We'll explore how we can show modal overlays and what exactly that is, how we can present dialogues to users, and we'll also learn about additional interactivity elements we might want to use in our apps. We'll also learn how we can handle basic user input, how we can validate user input to make sure that we're working with valid data, and as mentioned before, we'll dive into theming and how we can easily style our entire app from one single place. Now, to explore all these topics and more, we'll build another brand new app, an expense tracker app that allows users to register their expenses and that then also allows users to see their expenses both in a list and in a chart. We're going to build this application here from the ground up with all the features you can see here, and along the way, whilst building this app, we will of course practice what you already learned and dive into all these exciting new features. So let's dive right in. And for that, you of course should create another new Flutter project with the Flutter create command. Here I created a project called Expense Tracker with Flutter create expense tracker. And then attached to this lecture, you find a main.dart file, which you should use to replace your main.dart file in your project with, or simply copy the content of the attached main.dart file and replace your main.dart file's content with it. And also make sure you create an expenses.dart file, which at the moment will be empty because that is the file where I want to create my main user interface, or where I want to get started with creating that interface. And to get started, we of course, first of all, should take another look at that interface and at the core features we have there. And if you take a look at the finished app, you see that there are a couple of things on that user interface. In the end, we have that chart, and then below that chart, we have that list of expenses. But of course, we also have this bar, this toolbar at the top, you could say, which has this icon button which we can tap to open this modal overlay here, which then allows us to insert a new expense. So that's also something we'll have to add. Therefore, this expenses widget here, in the end, should give us these three main areas here on that starting screen. That toolbar, or app bar, as it's called in Flutter's world, at the top. Then below that, the chart, and then below that, the list of expenses. And we'll take care about the modal overlay and so on later. For that, in expenses.dart here, I'll create a new widget class, and I'll name it expenses. And this should actually be a stateful widget, which we build here, because of course, at some point we want to start managing expenses. We want to start adding expenses, for example. And that then will, of course, require a UI update, because every time we add a new expense, we want to, well, update the UI to show that new expense in the list and to also update the chart. And since we have that list and chart and both are part of that main expenses screen, which should be this expenses widget here, it's this expenses widget that should manage the data in a stateful way. Because you learned that we need a stateful widget if we have data which we want to change and where those changes should then update the UI. Therefore, here we extend stateful widget as we did it multiple times before in this course, and you also must add this import to material Dart, of course. And in that stateful widget, we have this create state method, which we should add. And you also learned, of course, that stateful widgets in the end are widgets that are created with help of two classes. The first class is the widget class itself, and the second class is a state class, which is typically named underscore and then your widget name, in this case expenses, state. And here we want to extend the built-in state class, which is provided by Flutter, which is a generic class where we basically have to tell Flutter which kind of state or to which kind of widget this state will be connected. And here that's the expenses widget. And in this expenses state class here, you then must add the build method like this. And in the build method, we'll then of course return our widget tree. Now in the create state method in the widget class, we then should return a new instance of our expenses state created like this. And we can also change this state here or this type here to be state of expenses to be a bit more specific which kind of state we're creating here. With that, we of course also must add our constructor function here to the widget class, or we should add it at least. And it can be a const constructor. And at the moment here, I just want to forward that named key argument to the parent class. So with that, we got the basic widget setup for this expenses widget. And before we'll now start working on that widget tree that we want to return, we can therefore go back to the main Dart file and there import from our own package, from our own project here, without the typo. So import, and here my project is named expense tracker, and I want to import from expenses Dart, and then set my home widget here to my expenses widget, which I can now use. And since there we allow for a const constructor and material app also supports const constructors, we can add const in front of material app. With that, we got that all set up, and now it's time to output something on the screen. For this here, of course, we have to return a widget in our build method. And for the widget that should be returned, I'll pick the scaffold widget here, which is another widget we used quite a bit before, because this widget does some general base style setup work, and it, for example, also sets the background color of the app to white. So here I want to return scaffold, and then add my body here, and set the body of this page here, of this screen, so to say, to a column widget. And I want to use a column widget here because in the end I want to have this chart above this list of expenses. So I want to have two widgets above each other, and that basically always means that you want to use a column because that allows you to add multiple widgets above each other. So here we then set the child widgets of that column, so the widgets that should be above each other. And here we'll soon have the chart and then the list. For the moment, I'll just add some text placeholders, which will be replaced later. So here I'll have the chart, and this can be constant, or actually we can even add constant in front of this entire list. And then I have another text widget where I will have my expenses list later on. As mentioned, these are just placeholders, of course. Now, if we run this application, here again on an Android emulator in my case, we should have this white background and also this text here squeezed into the top left border, but of course we'll change the styling soon. So now we got started with this basic user interface here. How should we now continue? Well, there are of course different ways of continuing, and of course we will need to build this chart and this expense list widget ultimately, but I want to start by creating a model as a first step in a separate models folder that I just created here in this lib folder. Of course, you don't have to create this models folder, but I want to organize my files and kind of group them by functionality or feature. Inside of this models folder, we will create a Dart file, which I'll name expense.dart, where I simply want to describe which data structure an expense in this app should have. So which kind of structure an expense should have. And for that, in this expense.dart file, we can create a class, which now won't be a widget, so where we won't extend stateful or stateless widget. And it's a class which I'll name expense. And of course, we have created a data model before in this course already. Here in this app, I'll do it again because we'll work a lot with such expenses, and a single expense will be made up of different data points, which I simply want to group together in such a custom class, in such a custom object blueprint. So which kind of data should be grouped into a single expense? Well, I definitely want to have the title there, so I'll add a property, a final property of type string, which I'll name title. I also definitely want to have the amount, and that should be of type double, which is a number with decimal places, so that we also support amounts like 1.99, for example. And besides title and amount, I also want to have a unique ID per expense, which then allows us to identify that expense later on, which is some information that we, for example, need to delete expenses. So therefore, I'll add an ID property, and this will also be of type string. You could also use an integer ID to have IDs like 1, 2, 3, and so on, but here I'll generate a string ID, some unique string, so that every expense has its own unique ID. And we'll soon add some code that takes care of generating such an ID automatically. Now, I also want to have a date attached to every expense. And for this, we can use the built-in datetime data type, which is a data type built right into Dart. So we don't have to import anything, we can use it like this. And datetime is simply a special data type that allows us to store date information in a single value. And with that here, I added 4 properties that, for this application which we're building here, should describe a single expense. Now, of course, we also need a constructor function that can be called to, well, build such an expense object based on this blueprint. And therefore here, I want to accept a couple of arguments, a couple of parameters. And we could use positional parameters here, but here, since I'll need a couple of parameters, I'll actually go for named parameters, because if you expect more than 2 or 3 parameters in a function or in a constructor function like here, I personally find it easier to call that constructor function if you can target the different parameters by name instead of having to remember their position and passing data in the right order to that function. Using named parameters can simply be a bit easier here. Therefore here I want to accept a named title parameter to assign a value to title. And this should be required with help of the required keyword here. The same is the case for the amount. I want to accept this as well, and it should also be required. Then I also want to require the date parameter. And for the ID here, I actually don't want to require this as a parameter. Instead, I want to build such a unique ID dynamically whenever a new expense object is created. And to do that, I'll use a third-party package, the UUID package, which you can install into your Flutter project with this command here, like this, so that we can use this package to generate unique IDs, because that's what this package is all about. So with this installed, here in this expense.dart file, we can import from this UUID package and there from the UUID Dart file. And this then gives us an object, or a class to be precise, which we can instantiate to get an object. The UUID class, which we can call like this, to create an object based on it, which I'll store in a final variable called UUID. And I do this outside of my class here because it doesn't belong to this class necessarily. Instead, it's just a utility object, which we can now use anywhere in this file to generate unique IDs. And I want to generate a unique ID for this expense class whenever it is instantiated. And for this, we can add a so-called initializer list after the closing parenthesis of this constructor function here by adding a colon. And after this colon, you can also initialize the properties of this class to which this constructor function belongs. So therefore here, we can then, for example, target the ID property here and assign an initial value that will be assigned when this object is created, so when this constructor function is called. And here I want to use this UUID utility object. And on that object, there is a v4 method along with a couple of other methods, but it's the v4 method which I want to use here, which generates a unique string ID. So this then generates a unique ID and assigns it as an initial value to the ID property whenever this expense class is initialized. This initializer list feature here is a Dart feature. UUID is this third-party package which we added. And here we can now also add const, since UUID supports this const constructor. And since we can add it here, we can actually also add it here to turn this entire variable into a const value which we can't reassign and which we create such that the value can be stored in memory and could be reused by Dart if we would use it somewhere else in our code as well. So now we got started creating this expense class and we're almost done, but there's actually one piece of information missing that should also belong to expense objects. And that's the category to which an expense belongs. Because in this finished app which we're building, every expense has a category attached to it, which is important for that chart that will be built. Because that chart groups expenses by category. So therefore here I also want to store some category information in my expense class. And you could now of course say that you want to have a category property which is of type string. This would allow us to add categories as string values to these expenses as we create them. But this could be quite error prone. Because if you, for example, want to support the category leisure, like this, we could of course create such an expense object by calling expense and passing leisure like this as a category value, but it could happen that we accidentally introduce a typo here and we wouldn't get any warning or error when doing so because any kind of string value is accepted. So even though that might not be one of the categories we want to support in this app, we wouldn't get an error because it is a valid string. It just wouldn't show up in our chart because there we might not look for this category because it contains a typo. So for that reason, using a string here is not optimal. It's too flexible. It allows too many values. Instead, we want to create a fixed set of allowed values so that we have to use one of those values when creating a new expense. And for that, we can create a new value that contains all these allowed values with another special Dart feature, the enum feature, the enum keyword. Enum is a keyword that allows us to create a custom type, you could say, that could be named category here, which simply is a combination of predefined allowed values. You define those allowed values between opening and closing curly braces. So this simply is the enum syntax in Dart. And then here between those opening and closing curly braces, you list your enum values. For example, here for the expense categories that we want to support, in this app here, I want to have food, travel, leisure, and work. And of course, you could add more, though these will be the categories I will later output in my chart. So with that, we're simply saying that in this project, in this Dart project, in this app here, we want to have a custom type category that supports these possible values. Please note that these values are not wrapped in quotes, so we don't have string values here technically, but nonetheless, this entire syntax here is recognized by Dart and treats these values kind of like string values. You will see how we can access them as text later on in this section. But now with that, we can use category as a custom type here for this category value in our expense class. And now, of course, we also want to accept categories as input values. And for this here, I will also accept a category parameter, a named category parameter, which is required. And that's now the finished expense model for the moment. We'll fine tune and change it a little bit later, but that's the model for the moment. And with that model defined, we can now switch back to the UI and make sure that we use that model there and, for example, output a list of expenses. So let's now use this expense data model to create some dummy expenses here in our expenses widget, or the expenses state class to be precise, so that we can then output these dummy widgets here in this list, before we then later will of course also add the logic to create expenses ourselves. But we'll start with some dummy expenses so that we have something to output. And for that, in this expenses state class here, I'll add a new final list of expenses. So of using this custom expense class as a type here, because as you learned before, whenever you create a class, you automatically also get a type of the same name, which simply contains information regarding the shape of the objects that will be created with help of your class later. And here I'll name this variable, this property in this expenses state class, which I create here, registered expenses. And I'll set it equal to a list with square brackets. And now here I simply want to create a couple of dummy expenses by using our expense class and instantiating objects with help of this class. And here we now have to pass in these different pieces of information, like for example the title of this expense. And here I'll give this first dummy expense a title of Flutter course, and add an amount of, let's say, $19.99, and set the date to today. I'll keep it simple and simply use today as a date. And you can create new date objects, because keep in mind that date wants date time values, so date objects in the end, with help of this date time type which we used before, which is actually not just a type but also a class built into Dart, as you can tell. And you can use datetime to create new dates by passing in various pieces of information here to the constructor function, or by simply using the special now constructor function by using datetime now. And this simply uses today and now as a date time, so as the date and time that will be stored for this expense. So with that, I'm passing in all that information. Of course, we now also need to set the category though. And this can now be set with help of our enum, which is available here, since I am already importing from this expense.dart file. My IDE, my code editor, automatically added that import before when I first referenced my expense class type here, but you can also add it manually. But with that file imported, we also have access to the enum, since that is defined in the same file. And we can use that here for creating our expense by referring to that enum and then using the dot notation to access the different predefined values that make up this enum. And here we could, for example, assign a category of work to this first expense, and then copy this expense and quickly create a second dummy expense here, which could be named cinema. And maybe here we paid $15.69. I'll also use today as a date to keep things simple, but the category here would of course be leisure. And with that, we have two dummy expenses which we can use. Now, right now, I'm getting a hint here that I'm not using registered expenses, but that will change because the next step now is to output those expenses in a list. And that's what we'll do in the next lecture. So let's now output these expenses in a list. And for that, I'll replace this text widget here, which acted as a placeholder, with an actual list. But I'll not add this list here in this expenses state. Instead, I'll create a separate widget to keep this widget, or this state which belongs to the expenses widget, lean. And to especially keep its build function lean and simple, because that is considered a good practice. keeping your build functions lean and not putting too much logic into them. That's typically what you want to strive for. So therefore here I'll add a new file, expenses_list.dart, sounds like a fitting file name, because in there I'll add a new class, the expenses list class, which now will be used for creating a widget. And therefore this must extend one of Flutter's widget base classes. And here a stateless widget is all we need, because we won't manage any internal data in that list. Instead, we'll just output the list of expenses that is defined here. We don't manage that list, we just output it. And therefore this will be a stateless widget. And of course it needs this build method. And in this build method, I then want to return my list in the end. Now before we create that list, we of course must make sure that the expenses list widget class here accepts this list of expenses as input. For that, we need to add the constructor function, which here can be a const constructor function. And of course, we want to forward that key as always. But then I'll accept more named parameters because I want to have some properties in here. To be precise, I'll start with one property. We'll add another property later in this section. But this one property which I'll add here is my list of expenses. So here I'll use the built-in list type, and it's a generic type as you already know, and it is basically a list full of expenses. Hence I'll add my custom expense class, and by using this suggested option here, my editor also automatically adds this import to the expense.dart file. So here I'm using this expense type here to combine it with the list type, and then here this property can be named expenses. And I now also have this required named expenses parameter, which is used to assign a value to this expenses property. And now we can use this expenses property here in the build method to output this list of expenses. Now, thus far in the course, whenever we had multiple items that should be displayed above each other, we used the column widget. And this is a great widget for outputting widgets above each other. You can use it for list content too, therefore. But if you have lists of unclear length that could potentially get quite long, as it is the case here for this expenses list, users could add 100 or 1000 expenses when the app is up and running. So when you have a list of unknown length that will potentially get very long, column is not ideal. Because with column, all the widgets that you add to it will be created behind the scenes by Flutter whenever this widget that outputs this column becomes active. So that means if you have a list with 1000 items, all these items will be created behind the scenes by Flutter at the point of time where this list widget is displayed on the screen. The problem with that is, of course, that only a small amount of those expenses is actually needed, because only a small amount of the expense list items that will display here will be visible on the screen. We will have a scrollable list, of course, and most of those items therefore won't be visible initially. Hence, creating all these invisible items behind the scenes at the beginning is really redundant and costs a lot of performance. That's why you should not use column for lists where you don't know the length, but where you might have a lot of items in the end. Instead, Flutter gives you a different widget that should be used for such situations, and that's the list view widget. Now, list view can also be created like this, and you can pass children to it. If you do that, you get a scrollable list, which still creates all items immediately when this list is displayed on the screen. So the only thing we gain here is that this is automatically scrollable. But it's still not ideal for this scenario here, where we might have many items that won't be visible initially. Instead here, we should not use list view like this, but use a special constructor that's offered by it, the builder constructor function. This is a special constructor function for this list view widget, which in the end tells Flutter that it should create a scrollable list. List views are always scrollable lists by default, but that it should create those list items only when they are visible or about to become visible, not if they're not visible. For that, builder takes an item builder parameter, which is of type function, so which wants a function as a value. And of course, you learned before in the course already that you can pass functions as values for parameters. So that's what we need to do here. And it wants a function that will get two input values itself. Those will be provided automatically by Flutter. And it should then return a widget. So this function which we pass as a value to item builder should return a widget, the list item that should be created when needed. So for this here, I'll create an anonymous function. You could also create a separate method here and then just point at it, but here I'll go for an anonymous function. And I'll get a context object and an index value automatically provided by Flutter. That's what you can see here. And I'll get back to this index value a little bit later. And then we must return a widget. And for this, you could define your function like this and then return your widget here. Or you use this super short function form by using this arrow, where you then immediately define the value that should be returned. And I'll do that here since all I want to do in this function is return a value. And the widget that should be returned here, in this case here, for a start, will simply be a text widget, though we'll change this later. And here in this text widget, I want to output the title of the expense which we are displaying here. Now for that, of course, we first of all need to tell Flutter which items it should build with this list view, because we're not doing this right now. To tell Flutter which items should be included, we can pass another parameter to this builder method, to this builder constructor function. Item builder is required, but we can also pass more arguments. As you can see, a long list of parameters that can be set actually. Now, these different parameters can be used to configure the behavior of list view, and definitely feel free to browse through them, also with help of the official documentation. But here it's the item count parameter that should be set. Because item count in the end defines how many list items will be rendered eventually. And for that, of course, I want to pass the length of this expenses list as a value. So expenses.length. Because this built-in length property can be used to get the number of items in this expenses list that we get as an input here in this widget. And that number of items is exactly what we need as a value for item count, so that Flutter knows how many items should be displayed here. And that's now where this index becomes important. Flutter calls this function here, which we pass as a value to item builder, as often as defined here by item count in the end. So if item count is 2, because we have 2 items in our list, this function here will be called twice. And for every function call, index will be a different number. It will be 0 for the first item, because list indexes in Dart, as in many other programming languages, start at 0, as you already learned. And it will be 1 for the second item, therefore. So therefore here we can get the title of the expense for which a list item is being created here by reaching out to expenses, so to this expenses property, then using the square bracket notation, since expenses is a list, to access a specific expense by index. And then, of course, since we want to get the title of that expense, we use the dot notation on that single expense to which we now got access to access the title. And with that, we're outputting this expense title in a text widget here with help of this list view widget provided by Flutter by using this builder constructor function to make sure that all the items are only created when they're needed. And if you have a long list of expenses, this can significantly improve the performance of your application. So with that, we got a first version of this expenses list widget. And back in expenses start, we can now use this custom widget. So here below this chart placeholder, I'll use expenses list. Of course, you also must add an import to your expenses list Dart file here in order to use this widget here in the expenses Dart file. And now we must pass a value for this named expenses parameter. And here that's my registered expenses list. That's the list of expenses that should be displayed on the screen. Hence, we can refer to it like this here. Now here I have to remove the const keyword and add it just in front of text, because even though expenses list supports the const keyword in theory, we can't use const in front of this widget if we're referring to a list property here, which could be changed later on. It could be changed despite being final, because we will still be able to add new values to this list, which is one single object in memory. We just wouldn't be able to assign a new value to registered expenses. But that's also something I'll get back to later in the course. With that, if we save this, we should now see our list here, except for that we don't. And the reason for us not seeing the list is that expenses displays a column, and in that column we now got a list. So in the end, another kind of column inside of a column. If you have combinations like this, you will always run into problems with Flutter, because it then doesn't know how to size or how to restrict the inner column. And you can then solve this problem by wrapping this inner column or column-like widget with the expanded widget and set the child of expanded to this inner column or list view in this case. And with that, we now see our list here. And here's the text widget above it, which is this chart placeholder. Of course, again, styling is all not final, but it's a start. And we're outputting this dummy list now, and we're actually doing so in a way that's optimized for performance. Now that we got our expenses list, it's time to work on these list items again. Because of course we got this text here, but the goal later is to not just output some text, not just output the titles of those expenses, but instead to output all the expense information that's relevant. For that, I'll create another new file, because I want to create another new widget, which then will be used for these expense items, again to keep the build method of this expenses list widget relatively lean, since you will see that the expense item widget, which I'm about to create, will actually combine many other widgets again. So for that, I'll add a new file, and since this will be a file with a widget that's closely related to this expenses list, I'll organize my code such that I add a widgets folder, and in that widgets folder, I'll add an expenses list folder, and I'll then move expenses list Dart into this expenses list folder. And in that folder, also create an expense underscore item Dart file, which will then be that file that contains the class, the widget class, that will be used for outputting the individual list items in that list. And I'll also move the expenses Dart file into the widgets folder, not into expenses list, but into the widgets folder. So that in the end in my project, I have the main.dart file, and then I have the models folder with expense start, and the widgets folder with expenses start and expenses list. This expenses list folder with its two widgets. And organizing the code like this is of course totally optional, but it can help with ensuring that your project stays manageable. So here we can now create a new class in this expense item Dart file, and that's the expense item class, which extends stateless widget again. Stateless widget because there won't be any internal data that would need to be managed. And of course here we again need the build method, and we also need a constructor, expense item, because we again need to get some input data here. We need the expense data that should be displayed on the screen. For this, I'll add a new property to the expense item class, which should be of type expense. And of course, for that, you again must add the import to this expense Dart file in the models folder in your project folder. so that I can add my expense property, which is of this type here. And then in this constructor, we can set this to mix things up here with a positional argument, though you could also wrap this into curly braces to turn it into a named argument. Positional arguments by default are always required, hence the required annotation is not needed and not supported here. And we still, of course, also need to add a second accepted parameter, which is a named parameter and hence wrapped between curly braces. And that would be this key parameter, which is then forwarded to the parent class, to the stateless widget class. With that, we can now output our widget, our combination of widgets down here. And here for this expense item, you can of course definitely play around with the different widgets supported by Flutter, with the things you will already learned about throughout the course. This is a great exercise, so definitely do that. Here for this widget, I chose to start by wrapping everything with the card widget, which is a widget we haven't seen before. This is a widget which I simply use for styling purposes, because this will give us a nice card look. It will basically put the content that we pass to card into a container that's a bit elevated, that has a slight shadow behind itself to make it stand out a bit more. I can show you how it looks by setting the child parameter, the named child parameter on this card widget, and set this to the text widget. And now here I want to access expense title. This is not the final definition of my expense item, but this allows me to show you how this card widget will look like. So here I output expense title, and now we can use expense item in the expenses list Dart file by going down here and removing this text widget in the item builder function. And instead we want to create our expense item here. If I use this auto suggestion menu here, it again automatically adds the import for me. Otherwise, you must add this import manually to your project, the widgets folder, expenses list, and then expense item Dart. And with that added, down here we can create an expense item by instantiating it. And I then want to pass a single expense to it. So I access my list of expenses that I get here. Then use the index again with the square bracket notation to access a single expense, and that's then the value that should be passed as a value to expense item, since there we expect to get an entire expense. And with that, if I force a reload, you now see the titles again, but if you look closely, you see that there is this slight drop shadow, and that's this card look. It doesn't look too amazing here because we got no other styling and no other widgets, but I want to have this elevated look here to make these items stand out at least a little bit. A card also automatically adds some top and bottom margin so that we have some spacing between those items. It's a bit hard to see here, but it's a subtle effect that will make the items look better, especially once we're done adding all the other widgets that should be added here to expense item, which is what I will do next. So here in expense item, we now have this card. As a next step, I want to add some padding to this card. Now, card does not have a padding parameter that could be set. It has a margin parameter with which we could change or extend the default margin that is added anyways, but it doesn't have a padding parameter. And if you recall, padding simply is this internal space, so some spacing which I want to add between the text and the border of this card. Now you can still add padding by refactoring this text widget and wrapping it with the padding widget. This then allows us to set some padding, and here I don't want to add the same padding in all directions. Instead, I'll use the special symmetric constructor function on edge insets, which is this utility class provided by Flutter that's used for creating margins and paddings. And here I want to set my horizontal padding to, let's say, 20, and then my vertical padding to, let's say, 16. And with that, you now see that there is some spacing between the borders of this card widget and the actual content, the text, which already ensures that this looks a bit nicer, I'd argue. Now, of course, that's still not all though. I don't just want to have the text in there. Instead, the goal is to later have the text here in the first row, so to say, and to then have a second row of data inside of that card, which displays us, for example, the amount, but also the date and category. So therefore here, since I want to have two rows, we need the column widget again. And here it's column and not list view because it doesn't need to be scrollable. And list view makes it scrollable by default, but we don't need this here. It's not a long list. And we also don't need that performance optimization because it is a list that's guaranteed to consist of only two rows inside of this item. Of course, we might have multiple items, but we are optimizing those by displaying them with list view. Inside of a single item, since we will only have these two rows, we don't need that list view. So here we can then set children, and children here should be set to multiple widgets. And the first widget will be the text widget again, which indeed will output the expense title again. We'll change its styling later, but in general, we want to output the title as the first row in this item. But now we're going to add more widgets. I will actually add another row, technically, a third row if you want to call it like this, by using sized box to add some fixed spacing, a fixed height between the text and the actual second row, the actual visible second row, you could say. Instead, we could also use margin wrapped around the first or second row, but this is simply a bit quicker. Now I want to add that actual second row, and that will now actually not just be a single widget, as we have it here in the first row, where it's just the text, but instead it will be the amount, and then to the right of that, it will be a combination of the category, or an icon representing that category, and the date. So therefore here we need the row widget, because that's what we can use if we want to display multiple widgets next to each other horizontally. For that we add children here. And the first child here is now another text widget, which is in general a widget you'll use a lot when building Flutter apps. Because here I want to output the amount that belongs to this expense. For this we can of course access expense amount like this. However, you see I get an error here because this is actually of type double and the text widget wants a string. Now we can convert it to a string by calling toString, but I will actually call a different method. I will call the toString_as_fixed method, which then wants an argument, which I'll set to 2 here. But what does this do? Well, toString_as_fixed simply ensures that a value like 12.3433 would simply be displayed like this, so that it is limited to 2 digits after the comma. That's what this does. So it's simply a stylistic choice here to make sure that if users would enter amounts with too many decimal places, we only display 2. I actually also want to display the $sign in front of this amount. And for that we can wrap this with single quotes. But now this would all be treated as text. And therefore I'll instead use this injection syntax, which I've shown you before in the course, with the $symbol, which now won't be displayed as a $symbol, but which instead tells Start that we want to inject a value into this string. But here the value is actually the result of a more complex expression instead of a single variable. And therefore here you actually have to extend this syntax and add an opening curly brace and at the end a closing curly brace. And this simply tells Start that it should take this value here as one value that should be injected into this string. Now, as I mentioned, I want to output a $sign in front of this string, and this $sign won't be output. Instead, that belongs to Dart. If I do want to output a $sign, I instead have to escape that character, as it's called, by adding a backward slash in front of this special $sign here. This backward slash now won't be output. Instead, this now tells Start that this $sign after the backward slash should be output as text and should not be treated as this special injection syntax. So here we won't see two $signs on the screen, but instead this second $sign belongs to this injection syntax, and this first $sign will be output because we're escaping it, as it's called. And with that, we should display this amount below the title. Indeed, if we save this, we should already be able to see this. Of course, we'll soon make sure that the title won't be centered anymore, but in general, this doesn't look too bad. We have the title, we have the amount, and we have this $sign in front of the amount. Now, we're still not done with the expense item widget here, though. We're now outputting the title and the amount, but there's more information that should be output. In this row here, so in the same row as we're outputting the amount, I also want to output information about the category and the date. And for this, I'll add a row inside of this row because I want to group category and date together. They should be output next to each other, but they should be pushed all the way to the right in this card here. So the amount should stay on the left and the other information, the other two items, should be displayed next to each other horizontally, but pushed to the right. Hence, we have to put them into a separate collection, you could say, a separate group of widgets. And since I want to output category and date next to each other horizontally, I will group them together with row. But I'm doing this so that between this amount text and this row, I can add another widget, and that will be the special spacer widget, which is also built into Flutter and which can be created with const. Spacer is simply a widget that can be used in any column or row to tell Flutter that it should create a widget that takes up all the space it can get between the other widget between which it is placed. So text gets all the space it needs to output the text, and this row will get all the space it needs to output its child items, but spacer then will always take all the remaining space, hence pushing text to the left and this to the right. And now with that, we of course can and should add children to that inner row. And here we now want to have this category or this icon that represents the category, and then next to it the date. Now for the icon, we can use the built-in icon widget, which can be used for displaying an icon. And for the moment, I'll just use a dummy icon here. We'll soon use a dynamic icon, which will depend on the category. For the moment, I'll just use any icon here, like for example, let's say the alarm icon. And then next to that, I'll add a sized box to add some distance between this icon and the date, with a width of 8, for example. And next to that, I have my text that should output the date. And we can also add const here, though that will soon change, since soon this won't be a hard-coded dummy icon anymore. But for the moment, it can be const. But now for this text here, I want to output the date of my expense. And for that, we can of course access expense date, but this would be of type datetime, not of type string, and it also wouldn't be formatted at all. Now we'll soon take care of formatting. For the moment, we'll just convert it to a string by calling toString. This will make sure that the date will be output as a text date. Well, and with all of that, if you save this, you should see all this information on the screen. You see the title here, you see the amount, and of course you also see this icon for the category, and then next to it the date, which looks ugly as mentioned because it's not formatted at all. And indeed, that's the next thing we'll take care of. We'll make sure that the icon is actually chosen dynamically, that it depends on the category of the expense, and we'll make sure that the date is formatted in a more human-readable way. Now, for both the dynamic icon and the formatted date, I'll actually go back to my expense start in the models folder. Because in there, I want to tweak the expense class to make outputting a formatted date a bit easier, and I want to add a new value to this file. So not to the expense class, but to the file as a whole. Here, I want to add a constant value called category icons, or the constant is called category icons, and the value should be a map where the keys will be category enum values, And the values of those keys in this map will be the actual icons that should be displayed for the different categories. So that in this expense Dart file, we don't just store the definition of our expense value objects, but instead we also store the available categories and the icons that belong to these categories. You could split this across multiple files, but here I'll keep it all in one file. So here my keys are these different enum values, like category food with the dot notation here. And then the value set with a colon here in a map, as you learned before in this course, would be an icon. And here I'll use Flutter's built-in icons class, which of course must be imported. So material.dart from Flutter must be imported. And then here for food, I'll use the lunch dining icon. And of course you can browse through all those icons and pick the icons you like most, but I'll use this one for the food category. Then for the travel category, I'll use icons flight_takeoff. For the leisure category, I'll use icons.movie. And for the last category, the work category, I'll use icons.work. So these are my icons, and I'll soon use them here in expense item Dart. But before we do that, I want to tweak this expense class. This class at the moment is simply defined to define the data structure of our expense objects. And this is of course very useful because that allows us to create such expense objects with ease, and it gives us auto-completion and type safety when working with them. But of course you can not just store properties in classes, instead you can also add methods to classes. And here we could add a method called getFormattedDate. Though if you find yourself defining methods that start with get as a name, or that are in the end all about transforming one of these property values, you could, instead of creating such a method, also create a so-called getter. For that you use the special get keyword built into Dart, and then the name of your getter, which now should be named like any other property, for example formatted date. And you should also define your return value, so the type of value that will be produced by this getter. And you skip these parentheses, instead you just have opening and closing curly braces. And between those curly braces you return your value, which should depend on your other property values. And here I want to reach out to my date property and format that. Now, formatting dates manually in Dart is quite cumbersome, and for that reason we'll use another third-party package here, the Intl package, for which you can simply search to find it on pub.dev. And as always, you can learn more about this package here. It's a quite powerful package that can help with localization as well. But here we'll use it to output a formatted date, and for that we'll just add it to this project by running flutter pub add intl. And with it added, in this expense Dart file, we can import it just as we imported Flutter or the UUID package by importing intl, and then here the intl.dart file, that's what we need here. And now with that package imported, we can use the date format class, which is provided by this intl package. And there the ymd constructor function, and we'll store the value of calling this constructor function in a final variable that could be called formatter. And ymd simply creates a formatter object which we can then use to format dates. So it's a utility object, you could say, created with help of the date format class and this special constructor function provided by the intl package. And this ymd constructor function defines how the date will be formatted. And indeed, date format supports many constructor functions that could be used to format dates in all kind of different versions. Y stands for year, M for month, and D for day. And ymd used like this is just one of those predefined formatting options. So now we can use this formatter object down here in this getter. And on that, object, you can call the format method and then pass your date to it. And this will return a string containing the formatted version of that date, so the more human-readable version. And now with this formatted date added and this icon map added here, we can use this information here in expense item. And for the icon here in this inner row, instead of always using the hard-coded alarm, we can now reach out to our category icons map, which we have in that other file, and use this square bracket notation here to access a specific item in that map. And since in that map we use enum values as keys, we also have to use such an enum value as a key to access an icon, which is no problem because in our expense object with which we're working here, we have this category property which stores enum values of that category enum. Now we also have to remove const here though, because this isn't a const value anymore. Instead, this is generated dynamically. Well, and for the date, we now access expense.formattedDate. You don't add parentheses here because it's a getter, not a method. If you did define formatted date as a method instead, which you could also do, you would call it as a method. But here we're using this getter version. With all that done, this now looks way better because now we got different icons for different expenses. And as you can also see, we got formatted dates here, which are way more human readable. So we're making progress, but of course, for example, the styling still isn't where it should be. But we'll take care about this later, because I think the more important thing right now is to make sure that we're not limited to those dummy expenses which we created here. It's good to have them to create that list and these list items, but of course, ultimately, the goal is that users can add their own expenses. That is what this app will be all about. And if you recall the final version of the app, you might also remember that there we had this toolbar at the top, this app bar, this plus button at the top here, which we could tap to bring up that modal overlay that allows us to enter new expenses, to insert new expense data. So of course we have to work on that modal overlay, but first of all we have to add this toolbar at the top. Now for that, in the expenses start file, in this column where we want to have the chart and then also this list of expenses, we could of course add this toolbar with the add button here and try to use a row widget, for example. We could do that, but having such a toolbar at the top is such a common requirement and is often needed for so many different things. For example, also to output a title, that Flutter actually has a more official support for that and does not force us to build our own here instead of this column. Instead, this scaffold widget is not just there to give us this white background and some basic styling, but besides doing that, it also supports multiple other arguments besides the body parameter, which we set to the main page body. It, for example, also has this app bar parameter. It also has other parameters, which we'll see later in the course, for example, drawer for adding a side drawer, but as mentioned, we'll see that later in the course in another course section. But here it's the app bar parameter which we want to set, because app bar can be used to add such a bar at the top of the screen. App bar wants a preferred size widget, which simply means that it only takes certain kinds of widgets, and typically you use the app bar widget here, which is another widget built into Flutter. Now the app bar widget then takes a couple of configuration parameters, as you see, and as always, feel free to browse through them, but most importantly for us here, it offers an actions parameter which we can set. And actions wants a list of widgets. And this is typically used to display buttons in this top app bar, in this toolbar at the top of the screen. Now here you could add a text button or an elevated button or any other kind of button you already saw in this course, but here I'll use the icon button instead, which is another built-in type of button, another built-in widget you can use in Flutter to display a button that only contains an icon. So not text and icon, but just an icon. For that, icon button needs the icon named parameter to be set, and it should be set to a widget, but of course here typically you use the built-in icon widget. And here I'll use the built-in add icon widget like this. Now this icon widget is actually const, so we can add const here, but that's not all we have to set. Instead, since it's a button, we should also set on pressed here. And on pressed, just as on the text button, which we already saw before in the course, wants a function as a value, an anonymous function or a function defined before in your class. Here I'll, for the moment, set it to an empty anonymous function. Now with that, if you save this, you have this app bar here at the top, which might look like this, or which might look like this. It simply depends on whether you're using the Material 2 or 3 look, and at the point of time I'm recording this, Material 2 was still the default, though no worries, I built the entire course with Material 3 in mind. But if you still had that other look with that blue bar, you can go to your main Dart file and simply add this line to your Material app constructor function and set the theme parameter to theme data, and there set use Material 3 to true. And I'll get back to theming later in this section, but you can do this now already to get this more modern app bar look here. Either way, you have this plus button here, this icon button, which we just added, of course. What you can also see is that now that the app bar was added, Flutter made sure that all the content, including the app bar, fits better into this screen. It basically automatically reserves the space needed for the camera and so on to not be occupied by widgets, and instead make sure that your widgets, like the app bar or this chart widget or this list widget, all go below this space up here, which it reserves for these device inputs and so on. So we get all of that just by adding app bar. And as mentioned, actions are important, but not the only thing you can set on app bar. Instead, there are many other parameters as well that can be set. For example, you could change the background color, but again, I will come back to styling and theming later in this section. But you can, for example, also set a title here, which again is a widget, typically a text widget. And here we could set this to Flutter expense tracker and turn this into a constant widget like this. So with that added here, we also have this title here. And that's how you can add such an app bar. Again, we'll take care of styling later. As a next step, I instead want to make sure that pressing this plus button actually does something, and that it opens this modal overlay, which then allows us to add new expenses. So let's now make sure that clicking this plus button in this app bar here does open this modal overlay at the bottom, which then does allow us to enter new expenses. For that, of course, we have to work on this function here, which we assigned to the onPressed argument of this icon button, because that is the function that will be triggered when the button is pressed. And we could edit it here inside of this build method, so we could work right inside of this anonymous function here, or alternatively, what I will do here, we can add a new method to this underscore expenses state class, and this method here could be called open add expense overlay, or anything like that. The name is of course up to you. It's a method that doesn't need to return anything, hence its return type is void. And inside of the curly braces, so between the curly braces, we're going to add the logic for showing this overlay. But before we do that, we want to assign this function as a value to onPressed by pointing at it like this as you learned, without parentheses, since we don't want to execute the function here. Instead, we want to use it as a value for onPressed, so that Flutter internally, so to say, can execute this function here whenever this button is pressed. Now, inside of open add expense overlay, I now want to execute some code that does open such an overlay. And thankfully here, we can use a built-in feature. If we type show here, we can get a long list of built-in functions that are all provided by Flutter that we can call to show built-in UI elements, like a date picker or a dialog box. And we'll see some of these things, for example, the date picker, a little bit later. Now here it's actually the modal bottom sheet which we want to show. So it's show modal bottom sheet, which we want to execute inside of this open add expense overlay function. And this show modal bottom sheet function here is provided by Flutter, and hence it's available because of this material Dart import, which, as you can tell by now, really unlocks many things, many widgets, and also, for example, this utility function. Now, this function will dynamically add a new UI element, such a modal overlay, when it's being executed. And since I created it here by using the suggestion whilst typing it, my code editor automatically set it up to use two named arguments, context and builder, to which we have to pass values when calling show modal bottom sheet, because these are two required arguments that must be set when using this function. Now, context here wants a build context value. For example, this context here, which we get automatically as an input to the build method, so which is passed to the build method by Flutter. Here we're outside of the build method, and yet there actually is a globally available context object, a context property, that's made available by Flutter automatically since we're in a class that extends state. When you're in a class that extends state, Flutter automatically adds a context property to your class behind the scenes, so to say. It's provided by this state parent class. And this context property that's made available by Flutter can be used as a value for this context argument that must be set on show modal bottom sheet. But for that, it's of course important to understand what this context thing is all about. And in the end, you can think of this context object, this context value, as some kind of metadata collection, an object full of metadata managed by Flutter that belongs to a specific widget. So every widget has its own context object, and that contains metadata information related to the widget and, very important, related to the widget's position in the overall UI, in the overall widget tree. So this context value which we get here holds information about this expenses widget in the end and its position in the widget tree, as you also see if you hover over this context value. Now this object, which is full of metadata, is required by show modal bottom sheet, which is why you have to pass it as a value for the context argument here. And the second argument that must be set is another builder argument. And whenever you see an argument called builder, it basically always means that you must provide a function as a value. And here it's a function that should return a widget and that automatically gets one input value passed into it by Flutter, which will call this builder function basically when it then tries to show this modal bottom sheet. So here we can set up a function which gets a context value, and here I name this context parameter ctx so that I don't clash with this context. I could use the same name, but technically it's a different context because it's the context of this modal bottom sheet that will be created. So the information object related to that instead of the information object related to the expenses widget, and hence I choose a different name here. And inside of this function body, you now have to return your widget that should basically be displayed when Flutter renders this modal bottom sheet that it's opening up. And therefore here we can again use this very short notation using this arrow syntax, since here we return that widget that should be shown. And to get something on the screen quickly, I'll again use the text widget here as a placeholder and just say modal bottom sheet and add a semicolon at the end here and a comma here for formatting reasons. And now this is the code that we must execute in here to show some modal bottom sheet. And of course the text widget will soon be replaced with the actual content that should be in that modal sheet. So with that, if you save everything and you click this plus button, you should now get such a modal sheet at the bottom. At the moment, just a tiny one because there isn't a lot of content in there, but there is this overlay which closes if you click on that backdrop that also opened up. You see that the background gets grayed out when this sheet at the bottom opens, and if we click on that backdrop, the sheet closes again. So that's how we can open and close it, and now of course we have to work on the content inside of that modal bottom sheet, and we also might want to add some additional configuration to it to make sure that it behaves correctly. So let's now replace this text widget with the actual widget that should be shown in this modal bottom sheet. And for this, I'll add a new file because this widget, which I want to show in this bottom sheet, will be this form, this combination of input elements that can be used by the user to describe a new expense. And since I'll have a couple of widgets there and some logic attached to them, I want to move that to a new file. So here I'll create a new file in that widgets folder, which I'll name new_expense.dart. So that's my file name. And in there, we want to create a new class, the new expense class, which of course extends a widget class. And here it'll be the stateful widget, since I will need to manage some internal state here in the future. So therefore here we're extending stateful widget. We need to add the createState method here, and of course the constructor function for this new expense widget. And at the moment here, I'll just accept and forward the key argument. And then we add this second class that's always added to your stateful widgets, the underscore new expense state class, which extends state, which is linked to new expense like this. And here for the createState method, we can also replace stateful widget with new expense like this. And here in the new expense state class, we of course must add this build method. And here in createState, we have to return a new instance of new expense state like this. And here in the build method, we now of course have to return our combination of widgets that should define this form, which can be used by the user to enter the expense data. For that, I'll return a widget here, and I'll start by returning a padding widget actually, since I want to have some spacing around this form so that it doesn't sit right on the edges of this modal bottom sheet. So here we add padding and set padding to edge insets. And then here, for the moment, I'll set this to all 16. And I'll add the const keyword later once we finalized this widget combination and we know where exactly we can add it. So here I added my padding. Now we also must add the child argument and then of course define which widget should be wrapped with the padding. And in the end, in this finished form that should be shown on the screen, I'll have multiple rows of input elements, you could say. I have this title input element in the first row, and then in the second row I have the amount and the date input element, and then in the third row at the bottom I have this drop down which can be used for choosing a category, and then next to it my buttons that can be used for canceling input or for submitting the input. And therefore, since we want to have multiple rows, it again screams for the column widget, and we can use column instead of list view here because we don't need scrollability right now, and we also don't need to generate those items dynamically. Instead, we know exactly how many rows we'll have, and therefore we're good to go. So with that, we can set our child widgets in this column. And I will start with the input field for the title of the expense that is about to be added. And for that, we can use the built-in text field widget provided by Flutter, which will display such a text input element. Flutter has a bunch of built-in input elements. For example, later we'll also use the drop-down button for displaying this drop-down, but here it's text field for allowing the user to enter some text. Now, the text field widget has many parameters that can be set, many niche parameters, which you will rarely need, but also some very useful parameters, like for example the max length parameter, which you can use to set a maximum amount of characters that can be entered into this input field. For example, here for our expenses, we could say that the title of a single expense shouldn't be longer than 50 characters. And hence we can enter a value of 50 here. In addition, we could also set the keyboard type here to then use the built-in text input type enum, which is provided by Flutter, to control which virtual keyboard should be opened when the user taps into this text field. So that we, for example, open a keyboard that's optimized for entering email addresses or standard text, which is the default setting anyways though, and which we therefore don't have to set explicitly. And nonetheless, it is important to know about this feature. Now here for this text field, I don't need that, but I do want to add a label to the text field to tell the user which kind of value should be entered there so that the user doesn't have to guess. And the label can be added, and that's a bit strange, by setting the decoration parameter on the text field. So I guess you can think of this label text as kind of a decoration around the actual text input field. So decoration then wants an input decoration object created with the built-in input decoration class provided by Flutter. And input decoration offers a label property. So that's how you add a label to a text field. You set the decoration parameter to an input decoration object, and on that object you can set the label property. And the label wants a widget, as you can see, so therefore here we can use the text widget, which is the widget you will typically use for such a label, to give this text field a label of title, for example. With all of that, we can add const here to get rid of the blue squiggly lines, and also add it here in front of edge insets all, and we should have such a text field. Now, this is not the final form. We'll add more to it later, and at the moment we're also not handling any input into this text field, but it's a first step, and I want to make sure that it's this form, this basic form here, that will be displayed in this bottom sheet when it's opened. And for that, of course, we have to go back to expenses, to this code where we open the modal bottom sheet, and instead of showing this dummy text widget here, I want to create my new expense widget instead. And we can add const in front of this here. With that, if we save this and I force a reload, if I open this again, you see this looks totally different now. Now it looks better, it occupies more space because of that column which we added in there, which automatically in the end tells Flutter to reserve more space for it. We got the padding around the text field, and of course, most importantly, we got the text field. And we got the text field with that label that we set, and with a hint related to the max characters we set. And of course, we can tap into it, and this soft keyboard should open up here, and we can use that to type, or here, when using the emulator, we thankfully can also use our physical keyboard to enter our title. So that's how we could enter a value here. Of course, at the moment, we're not using that value in any way, and we also can't submit the form. So therefore, before we add any other input fields, let's make sure that we do instead save that entered value and that we can submit that form and add a new expense with that title. So back here in new expense, let's make sure that we store the data entered by the user, and we then also use that data when the form is submitted. So when this input field is submitted in the end. And for that, of course, we'll also need a button that allows us to submit this. Now, first things first, I want to start with storing the value entered by the user. And when it comes to storing that value, we got two main approaches for doing that. The first approach is to add another parameter to the text field, and that would be the onChanged parameter, which allows us to register a function that will be triggered whenever the value in that text field changes. For example, because the user pressed a key. And onChange wants a function that will receive a string value, and that string value that's received will be the value entered into the text field. So therefore, we could add a method here to newExpense_state, a method that returns nothing and could be called underscore save title input. And here we get our input value, which is of type string, as mentioned before. And now we can pass save title input as a value to onChanged. Like this, not executing it, just pointing at it. With that, we have to remove const though, since we're setting this function as a value for onChanged now. We could add it here in front of input decoration. And inside of save title input, we can now use that input value, which is passed in automatically by Flutter whenever it calls this function, which, as mentioned, it does whenever the value in the text field changes. And we could now add a variable to our state here, entered title, or underscore entered title, which initially is an empty string, because initially nothing has been entered. But now here, whenever this is triggered, we can set underscore entered title equal to the entered input value. Like this. We don't need to wrap this with setState here, because I'm actually not using entered value anywhere in my UI code. So the UI doesn't need to update just because I'm storing the value entered by the user in some variable. Instead, I'm storing that value in some variable so that we can use that variable with that stored latest value entered by the user when the user submits the input. And for that, we need to add a button that allows the user to submit the input. So after the text field, still inside of the column, of course, I want to add my buttons. And for that, I'll add a row here, since I'll have more than one button eventually, which takes multiple child widgets, of course. And for the moment here, I'm only interested in adding one button here, an elevated button, let's say, on which we have to set the onPressed argument, pointing at a function that should be triggered when the button is pressed, and then the child widget that contains the content of the button. So for example here, a text that says save expense. And this text here can, of course, be a const value. And in onPressed, we now want to use this entered title to add a new expense. Now we'll do this eventually. At the moment, I'll simply print this entered title to see whether A, this code is executed, and B, we get access to that latest value that was entered. It should work because we're saving the latest value here on every keystroke in entered title. So therefore we should have the latest value entered by the user stored in that variable. And therefore if we then at a later point of time reference this variable here, when this button is pressed, we should be able to print that latest entered value. So with that, if you save that and maybe force a reload, you should be able to enter some text here like test, and click Save Expense. And if you now go back and you open this panel here in Visual Studio Code, and you dare go to the debug console, you should see this test value somewhere there, or whichever text you entered into your input field. So this works. We do have access to the entered title, and that's one way of getting hold of that value. So reacting to every key press and updating and storing the current value of the text field in some variable is one way of handling and storing the user input. But of course, it can be a bit cumbersome to manually store all the input for all the text fields that might make up your user interface. And that's why Flutter gives you a convenient alternative. Nonetheless, it's also important to know about this approach because it's also a valid approach that you might see in many projects you're working on. But the alternative you get does not require you to add this function and this extra storage variable. Instead, we'll add another property, which can be a final property now, to this new expense state class. And this is a property that could be called title controller. Now the name might be a bit strange, and of course it is up to you, but I chose title controller here because the value which will be stored in this property will be an object that is created with help of the built-in text editing controller class, which is a class provided by Flutter. Now this creates an object that's optimized for handling user input, you could say. An object that can be passed as a value to text field to let Flutter do all the heavy lifting of storing the entered value and so on. Now when using text editing controller, there's one thing that's really important to keep in mind though. When you create a text editing controller here, you also have to tell Flutter to delete that controller when the widget is not needed anymore. So for example, when the modal overlay is closed. Because otherwise, this text editing controller which you create here would live on in memory even though the widget is not visible anymore. That's why when using text editing controller, you should also always add the special dispose method to your state class here. So a method called dispose, which returns nothing and calls super dispose. And before calling super dispose, you should reach out to your controller and on that controller call the dispose method, so that you tell Flutter that this controller is not needed anymore. Otherwise it will not be deleted and ultimately your device memory might be taken up by all these unnecessary controllers and that could cause your app to crash. So therefore you should always dispose of these text editing controllers you might be creating. But what's the idea behind this controller now? Well, with it created, you can go to your text field and get rid of this onChanged parameter, which you now don't need anymore. And instead you can set a controller parameter and you set that to the controller that should be responsible for this text field. So if you have multiple fields, you need multiple controllers. And you can now also use this title controller here in the function that's triggered when this button is pressed. Here you can access your title controller, and then on that object you will have a text property which, as you might guess, simply contains the text the user entered into the input field. And therefore you don't have to manually take care about storing that input, instead Flutter does it for you. And with that, of course, if we go back and reopen this and enter test or test2 and click save expense, and we go back to that debug console, we now see that output here in the console. And that's therefore the approach we'll use in this section now. And therefore, since it's a bit less work to do, and we will add more text fields, and I don't want to manually manage all the inputs, I will use this controller approach in this section here. So now that we have a basic understanding of how we can add text fields, here's a little exercise for you, a small challenge for you. I want you to add another text field to this column in a separate row, and that text field should allow the user to enter an amount, so the amount that belongs to the expense that is about to be created. For that, of course, you want to make sure that you use a soft keyboard type that's optimized for entering numbers. You want to add an appropriate label to this new text field, and of course you also should make sure that the value entered by the user is stored and is also printed here down here in this button. And speaking of buttons, I also want you to add another button to this row of buttons here, a text button which allows the user to cancel editing and which we'll use in the future to close this modal overlay. Now, you don't need to add the logic for closing just yet because you haven't learned how to do that, but definitely add the button and add that text field and therefore practice what we learned. So, did you succeed? Let's now try it together. For that, I'll first of all copy that text field, which we had here for the title, and adjust it for my amount here by replacing the text with the text amount. The max length is actually not needed anymore, but I'll set the keyboard type parameter, which I showed you before, to input type or text input type number, like this. And of course, I also want to create a new controller here, an amount controller, which is also a text editing controller, and which also must be removed when we remove this widget. So here in this dispose method, which is called automatically by Flutter, when the widget is destroyed, I will use my amount controller and call dispose on that. Like this. And with that, Flutter will manage that value for us, at least as soon as we assign the amount controller here as a value for controller on the text field. And we can then use that here on this button down there to also output the amount controller text. Now please note that this will indeed be text, so a string value, even though a number is entered. If we want to treat it as a number and use it as a number, we'll have to convert it manually thereafter, but that's something we'll do later. For the moment, I'll just output it here, and I also want to make sure that this second button, which I mentioned, is shown here, and this will be a text button, where on pressed, I currently won't do anything. I just add an empty anonymous function here. And as a child, I'll set the text which should be displayed. And here that's simply cancel, which can be a constant piece of text. Now with that, we added the two things that should be added for this task. There's now just one additional thing I want to do to this text field, to this amount text field, which was not part of the task. So you're done, you're good. But there's one thing I want to do. In this input decoration object here, I want to set the prefix text property here to a $sign. And since this is this special character with this special meaning, I'll escape it by adding this backward slash in front of it. And I'm doing this here, followed by a white space, so that we always have this $sign in front of the amount field, because, well, in the end, it is a dollar amount that should be entered here. So that's some additional configuration to make sure that we tell the user which kind of value they are about to enter. With that, if we save this and we force a reload, if we open this modal overlay, we got these two buttons here at the bottom. That's great. The cancel button, of course, doesn't do anything, but we'll change this soon. But if I enter a value here in the title and here in the amount, that both works. And you also see how the keyboard changes because of this keyboard type that we set here on the second input field. We get this number optimized keyboard here, and we can therefore enter a number. And if I now click Save Expense here, this should both be stored. And indeed, if we take a look at the debug console, we can see both values here. So that's how we can add another input field here. Now, being able to enter all these values is great, but let's make sure that now this cancel button also closes this modal overlay when tapped. And to achieve this, we have to go to this function here, which is assigned to this cancel button. And of course, we could also convert this into a method that belongs to this class and then just point at it. But here I'll work with this anonymous function just like that. But inside of this function, we now want to use another built-in class provided by Flutter, the Navigator class, which we'll see again a little bit later in the course, once we dive deeper into navigation and how we can switch between different screens. And this Navigator class has a pop method, which we can execute, which wants the current context as an argument. So this context value, which we get automatically here in this build method. So this is passed in by Flutter, and we have to kind of forward it to the pop method. And pop simply removes this overlay from the screen. So if we save that and I click cancel, you see the overlay closes. So that's pretty good. The next step now is to make sure that this text field widget here doesn't take up its entire row, but that it instead sits next to another input-like element, not a text field actually, but some other widget which we will kind of treat like an input element, that then allows us to select a date that should be attached to this expense. So it's time to add a date input, so to say. And for that, I'll add a row widget here below this first text field, because this amount text field actually doesn't need an entire row. The amount is typically pretty short. We don't need to use the entire row here. Instead, I want to use a part of that row, and the other part should be used by the date input. So therefore here, this row takes its children parameter, and the first child that's added here is the text field. The second child after the text field will be that date input. But here we don't have a built-in input that we could use. Instead, we kind of have to build our own input here, but thankfully, as you'll see, that will be quite straightforward, no worries. To add this date input here, I'll start by adding a sized box here to add some spacing between this amount text field and that date input. Let's say 16 pixels. And then next to that, another row, which I want to use to group two other widgets, which then together form the date input together. And since we here have a row inside of a row, and that would cause problems, we should already wrap this with expanded. And we will actually have to do the same for the text field, because text field turns out to be a widget which has problems with being placed in a row like this, because it also wants to take as much space horizontally as possible, and the row by default doesn't restrict the amount of space that can be taken, and that therefore causes problems when Flutter tries to render this combination on the screen. Hence, we also should wrap text field with expanded to make sure that it takes as much space as it can get on the screen, but nothing more. So we need to wrap this around text field and also around row here. With that, inside of this inner row, I want to have a text widget, which we'll use to show the currently selected date. So for the moment, I'll just say selected date here as a placeholder. And after this text field here, I want to display an icon button which can be pressed to open a date picker. So an overlay that can be used for selecting a date. This icon button here needs an icon. And for this, we can create a new constant icon here with icons calendar month, which is a fitting icon I want to use here. And in addition to setting the icon, of course, I also want to set on pressed to make sure that I register a function that will be triggered when this icon button is pressed. And I'll get back to that function logic in just a second. With all that though, if you save that and force a reload, and you click this add button, you should see something like that. It's not 100% finished yet, but you see that the amount and this date input combination here sit in the same row and take up an equal amount of space here. Now indeed here for the date inputs, it would be nice if they would be pushed all the way to the right here. And to achieve this, we can go to this row that contains this text and icon button. And there we can set the main axis alignment, which in a row controls the horizontal alignment, and set this to main axis alignment and to push the content to the end of the row, like this. We can also add the cross axis alignment and set this to cross axis alignment center to center the content vertically. Now, if you want to do that or not is something that's up to you, but you can do that as well. With that, I do have the basic user interface I want to have here, and we now of course have to make sure that when we press this calendar icon button here, we actually do open such a date picker that allows the user to pick a date. For that, we have to work on that function that's passed as a value to onPressed on this date icon button. And I'll set this function up as a separate method here in my state class. It does not matter if you define it in front or after this dispose method here. Here I'll define it in front of it. And I'll name it %datePicker because that is what we do in this method here. We want to show that date picker. Now, therefore, it's this %datePicker method that should be used as a value for this icon button here. So this anonymous function can be replaced with a pointer at this underscore %datePicker function here. And inside of this function, or inside of this method to be precise, we now want to show such a date picker. And this can be done by using Flutter's showDatePicker method. Now, before in the expenses start file, you already saw showModalBottomSheet, which was a built-in function. Now you see showDatePicker, which is another built-in function supported by Flutter. Just like showModalBottomSheet, which wanted a context, showDatePicker also wants a context. But in addition, it also needs an initial date, so basically the date that is selected initially when the picker is opened. Then the first date that can be selected, so the lowest possible date, so to say, and the last date, so the maximum date that can be selected. Now, to get all these dates, I'll create a new helper variable, or a final helper variable to be precise, which I'll call now, which is simply datetime now. And this should be my initial date. So my initial date is simply today, created with datetime now, because initial date, just like first date and last date, all want datetime values. So therefore here I created a datetime and used this as an initial date. For the first date, I then want to create a new datetime by calling the datetime constructor function like this, and by now manually passing a year, month, and date to it. And for the year, I want to use now.year, so on this datetime object, which now is, since we created it with this datetime constructor, you can access various pieces of information with help of all these properties. For example, the year property to get the year of the date here, so of the now date, so the current year therefore. And I want to deduct 1 from it by using this minus operator. So this gives me the current year minus 1. Then the next value you have to set here on the datetime constructor function is the month. And here I'll use now.month, so the same month, but 1 year ago. And the last value I want to set is now.day, so the day of this date here. So basically I'm setting the first date to today minus 1 year. And for the last date, I will now simply use now again, so today. So that my initial date and the last possible date I can set is now, but the first possible date, the oldest date that can be set, is now minus 1 year. And with that, if you save everything and you force a reload, you should be able to open this overlay and click this date picker button here, and now you get this date picker overlay presented on the screen, and here you can navigate between years and the different months in a year, and then pick any date of your choice and confirm this. And of course, at the moment, we're not doing anything with that confirmed value, but that's how we can show the picker. But of course, now we also want to store that picked date. So how can we now store that date that was selected? Well, showDatePicker in the end returns that picked date, but wrapped into a so-called future, a value of type future, which we haven't encountered thus far. Now, futures are a very important data type built into Dart. You will see futures again later in the course when we work with HTTP requests, and a future simply is an object from the future, you could say. It simply is an object that wraps a value which you don't have yet, but which you will have in the future. Like here for show date picker. When this line of code is executed by Flutter, it opens this date picker and shows it on the screen. But of course, no date has been picked yet. That will only happen in the future, you could say. Therefore, Flutter internally basically memorizes that in the future some value will be picked here, and it allows you to register a function that should be executed in that future once that value is available. And that function can be registered by calling a method on that object, on that future object that is returned by showDatePicker. So this future object, and that's important to understand, is returned immediately, but it doesn't contain the picked value yet. Instead, this future object gives you a then method, which you can call, to which you can pass a function, an anonymous function for example, which then will get that value, which in this case here has been picked, once it has been picked. So this function which you pass to then will be executed by Flutter once the value is available. So once a date has been picked here. It's kind of similar to how buttons work, where we also defined a function that will be executed in the future, but here we're dealing with a widget where we set this function as a value for one of the many widget arguments. In case of showDatePicker, we instead get such a future object to which we pass such a function. But the idea is generally the same, that we want to get hold of some value or some event in the future. Now, using such a then method is one way of getting hold of that value. A more convenient method is to add the special async keyword here between the parentheses after the method name before the opening curly brace, and then add the await keyword in front of the code that does yield such a future. So you can't use async await here in the build method for your widgets, but you can use it whenever you get such a future value. If you use await here, you get access to that picked date in this case here as a value in a regular variable. But even though this now looks like all the other code, or almost like all the other code, the await keyword internally simply tells Flutter that this value that should be stored in picked date won't be available immediately, but at least at some point in the future, and Flutter should therefore basically wait for that value before it stores it in that variable. Nonetheless, Flutter will make sure that the next line after this code here, so this line here, will only be executed once the value is available. So it will really kind of wait for that value. And therefore here we could print that picked date. Or we could store it in a variable, possibly even with setState, so that we could output it here in this text next to this icon button. And that is indeed what I want to do here. So I'll add a new variable here, underscore selected date, which should be of type datetime. And since I am setting a type here, the var keyword must be omitted. And actually, it initially will not hold a value, hence it should be datetime ? To tell Flutter that selected date either stores a value of type datetime or nothing, null, as it's called in Dart. And instead of %datePicker, here, after waiting for the selected date, we can call setState and set selected date equal to the picked date. And picked date is of type datetime, so setting it like this is fine. And with that, we can use this selected date to output it down there. Of course, here I again want to output a version that's human readable, and for that reason, I'll use the same approach I used before in my expense model, where I use this Intel package and such a formatter by adding it here to this new expense start file as well. And this formatter can be set up outside of any class. Alternatively, we could of course also simply import from our own package here so from our own project package, and they are from the expense start file in the models folder, because in there we set up this formatter, so it is actually available as soon as we import from this file. And we can use this formatter down there to not output selected date here, but instead I want to output no date selected if we haven't selected a date yet. So I want to check if underscore selected date is equal to null. And then we can use a ternary expression here to output no date selected in that case. Or alternatively, we can use the formatter here and call format on the selected date to output a formatted version of that date. And now we have to remove the const keyword here. Now I'm getting an error here that in the end date time might be null here, and format wants a date time that can't be null. There is no question mark after date time here. Of course, we know that selected date won't be null here though, because we're checking this here, and therefore we can add an exclamation mark at the end to basically force Dart to assume that this won't be null. So with an exclamation mark after a possibly null value, we tell Dart that this will never be null, which we know with certainty here because we're checking for null equality here. So with all of that out of the way, we can save this. And if we go back to our application and we pick a date here, we can see that formatted picked date here. And of course, we can also change that date and it would update here. So that's now working as it should. And we can therefore now, as a next step, work on that category selection dropdown. So it's now really time to finalize this form and this overall overlay here. For that, here in this last row where I have these two buttons, I also want to add a third button, a drop-down button that can be used to select a category. So therefore here, in this row, next to the buttons, I'll add this drop-down button widget, which is offered by Flutter, which renders a button that will display a drop-down once clicked. Now this drop-down button widget then has two arguments that must be set. The onChanged argument, the onChanged parameter, as always for these buttons, must be set to a function that should be executed when the button is pressed. Though here it really is a function that will get a value of type dynamic, because the value that it will get here will simply be the value that has been selected from the dropdown, and it's of type dynamic because Flutter right now does not know which kind of items will display in this dropdown. Because that's the next part. Items now wants a list of drop-down menu item values. Now in this app here, I of course simply want to display all these possible categories in this drop-down menu. And for that we can reach out to our category enum, which is available because we're importing this expense Dart file in which this enum is defined. And on that enum, you can not just access the different values that you defined, but actually also a values property. So a property named values, which gives you a list with all the values that make up the enum. And that's what we need here because we want to display all these values in this drop-down list. Now values is a list of enum values, a list of categories therefore, and items wants a list of drop-down menu items. Therefore, we have to do something we did before in the course already. We have to call map on this list to transform it from one type of value into another type of value. Now map, as you learned before in the course, wants a function which will be executed automatically by Dart for every list item. And we will get the list item for which the function is currently executed as an input value automatically passed in by Dart. So here it will be a single category since this function will be invoked for all the category items. And we want to return our drop-down menu item here. So drop-down menu item. That's what we want to return here. Now, drop-down menu item in the end is a widget, and it is a widget where we have to set the child parameter to another widget, which simply defines what will be shown on the screen. And here I'll keep this simple and simply output a text widget here, and the text value should be this category. But category, of course, is of type category, so our enum type here. And to convert this to a string that can be output with the text widget, we have to access the special name property that's made available by Dart, along with a couple of other properties on all those enum keys, all those enum items. And name then has a toString method, which we can call to convert these enum type values here to strings that can be used with the text widget here. So the values property on the enum itself was a property provided by Dart, and the name property on the individual enum items is another property provided by Dart. Now here we're still getting an error in the end that we have an iterable here in a place where a list is expected, and therefore we should do something we did before in the course as well. We should call toList on the result of map. But this is actually not all I want to do here. Instead, on this drop-down menu item, I don't just want to set the child, but in addition to that also the value parameter. And this will be the value that will be stored internally for every drop-down item. It will not be visible to the user. It's this child that's visible to the user, but it will be stored internally, and it will be this value that we get here in this onChanged function whenever the user selects one of these drop-down items. And here the value is the category itself, so the specific enum item that is mapped to a specific drop-down menu item. So therefore here in onChanged, Flutter now understands that the value we will get here will actually be of type category. It will be one of these enum items. And then we can use this here, and for the moment I'll just print it. Of course, in the future we'll do something else with it. But with that, if we save everything and force a reload, if we open this, we have this drop-down button here, and in there we find our different items. Though as you see, when I select them, we actually don't see them here. We also have no initially selected item, and they're also all written in lowercase. So there are a couple of things we have to do here. And the first thing is to get rid of toString. We actually wouldn't even need that because name is already a string, but I want to replace it instead with toUpperCase. Because this is a built-in method that can be called on strings that transforms a string to be all uppercase. So that's the first step we should take. In addition, I now want to store the value that was selected, because just to quickly show you this, if you do go to the debug console, you can indeed see the different selected values there. So printing worked and selected worked, but I also want to store the values now so that we can later use them when our form is submitted. And for that, we can't use a controller. Drop-down button does not support a controller, but we can of course manage this manually by adding another new variable to our new expense state class, just as we added selected date there to manage it manually. And here the value will be of type category, of course, and I'll name this selected category. And initially, I'll set it to category leisure. So that's the selected category variable. And now, of course, this should be updated whenever a new value is selected. So with help of onChanged here. Alternatively, we could also create a new separate method at which we point here, but here I'll do it just in place and call setState to set selected category equal to value. Now value could be null. It has this question mark here, and that's the problem Dart has with this code here, because maybe the user didn't select anything. And therefore I'll add a little if check and check if value is equal to null. And if that's the case, I will simply return. And we can do this outside of setState actually. So that this code here only executes if the value is not null. Because if we return in a function, no code thereafter will be executed. A return statement is always the last code that will be executed. So therefore, if we return here, if the value is null, this code won't be executed. And on the other hand, if this code will be executed, we know that the value will never be null. And Dart now also understands this and no longer complains. So now that we're storing selected category and we're updating the state whenever it changes, we can also tweak this drop-down button and actually add the value parameter to it and set this to selected category. And with that, we ensure that the currently selected value will be shown on the screen instead of showing this empty drop-down as it was the case before. With that, if you save that and force a reload again, now you see that leisure is selected initially, and if I switch to a different category, that is shown on the screen instead. And you also see that it's all written uppercase, as mentioned before. So that's looking really good now, and therefore there are now just some tiny adjustments left. For example, I want to add a spacer between my drop-down button and the other buttons, a const spacer, to make sure that there is some spacing between all these buttons. And I also want to have some spacing to the top, so some space between the amount input and this drop-down, for example, some vertical space. And for that, of course, we can go to this place here before we start that row that contains the drop-down button, and here add a sized box, a const sized box with a height of 16, for example, so that we have some distance here. Now with that, we made good progress. We're almost done here, but not entirely yet. User, I of course want to make sure that if we try to save some empty input fields, we fail and we show the user some error message that tells the user that valid input values have to be entered first. And of course thereafter, I also want to make sure that this list is updated and the new expense is added to the list, before we then thereafter take care about styling and the chart. And last but not least, related to this form here, or to this overlay, of course, if you tap into one of these fields, you see that the keyboard is coming very close to these input fields. And it might actually obscure these input fields on some devices. So we also want to make sure that that will never be the case. But we'll start with validation. So let's make sure we also validate those user inputs when submitting them. And for that, to achieve this, I'll first of all add a new method here to new expense state. And this could be named submit form or submit expense data, something like this. And it should be triggered whenever this button at the bottom here is pressed, this one here. Here, instead of printing some dummy values, I want to trigger submit expense data by pointing at it. And inside of submit expense data, we now have to validate the data selected by the user. For that, we can use an if statement, about which we learned before in the course already, and check if title controller text, after trimming it, which is a built-in method that simply removes excess white space at the beginning or end, if this is then empty. And isEmpty is a built-in property, just as trim is a built-in method. Trim can be called on strings, and text is a string, and isEmpty can be called on lists and strings, and the result of calling trim is a string, which is why we can use isEmpty here. So this overall will be true if we have an empty title or just a bunch of blanks. And if that's the case, then we want to show an error message, which we'll do soon. But of course, that's not the only case when we want to show an error message. Instead, we also want to show an error message if we have an invalid amount. Now, the amount is not just invalid if it's empty, but also if it, for example, is a text that doesn't qualify as a number, or if it's a number smaller than 0, because our amounts for the expenses here must be greater than 0. Therefore, as a first step, we have to transform the amount controller text, which we get, which is always a string, to a number. So our entered amount, as we could call it, has to be a number, not a string. And this transformation can be achieved by using double.tryParse, a method built into Dart. TryParse takes a string as an input and then returns a double if it is able to convert that string to a number, to a double, or it returns null if it's not able to convert it. So using TryParse on a text like hello would yield null, for example. TryParse on something like 1.12 as a string would yield 1.12 as a double, as a number. So that's something we have to do here. And with that done, we can add another variable, which could be called amount is invalid, which we want to set equal to true or false, so to a Boolean. But of course, we don't want to hard code true or false here. Instead, that should be derived dynamically by taking a look at entered amount, just as we're taking a look at the title text here. So what we want to check here is whether entered amount is maybe equal to null. Because I just mentioned, TryParse will yield null if an invalid number was entered, so some text that can't be converted to a number. So now amount is invalid will be true if entered amount is null, because indeed then the amount is invalid. But that's not the only case in which we would consider it invalid in this app here. Instead, the amount will also be invalid if it's smaller than 0, as mentioned. So here we actually want to derive true or false based on a combination of conditions. And in Dart, you can do this with two very important operators. The logical AND operator, which is written like this with two ampersand symbols, or the logical OR operator, which is written like this with two pipe symbols. And you will see this in many other programming languages as well. Of course, thus far you already saw some operators like plus or minus, which are used in mathematical operations. There also would be the asterisk operator for multiplication or the / operator for division. But where plus and minus and so on are used to derive numbers, and OR are used to derive booleans. And they help us derive booleans by combining multiple conditions. Here, the first condition is that entered amount is equal to null. In that case, amount is invalid will be true. Or it should also be true if entered amount is smaller or equal than 0. So if one of these two conditions is met, amount is invalid will be true. If both conditions are false, amount is invalid is false. But it is enough that one of them is met to set amount is invalid to true because of this logical OR operator. Well, and with that, we now know when amount is invalid will be true. We can now add this here to our if condition, where we're checking whether the title is invalid with this code. Now we want to combine this condition with amount is invalid by again using the OR operator. The OR operator instead of the AND operator, because we want to make it into this if block where we want to show an error message in the future if at least one of our checks yields true. Because even if all the input values are valid, it's enough for one input value to be invalid to show an error message, because we need all input values to be valid, not most of them. So therefore here we want to now add amount is invalid. And this is now, of course, not a condition, but it is a value that contains true or false. And that's all the if statement wants. It wants a bunch of true or false values or expressions that yield true or false to know whether the code inside of the if statement should be executed or not. So we spent quite some time on this if statement already, but it is important to understand how if statements work and how these conditions work and how they can be combined, and we're of course also still not done. Because the date could of course also be invalid. Therefore, we want to add another condition here, again with the OR operator for the reasons mentioned before. And here we want to check if selected date is equal to null. Because if that is null, which it can be if no date has been selected, then we also want to show an error message. We don't need to check the selected category because here we have a default category, so here it should not be possible to set this to no value. But for the other values it would be possible, and that's why we're checking them here. Well, and now we can make sure that we show an error message in this if statement. So how do we show an error message here? Of course, it's important to keep in mind that this message will only be shown if we make it into this if statement, which will only be the case if at least one of these conditions here is met. Now, to show this error message, we can use another built-in function provided by Flutter, and this time it will be the show dialog function, which will show some info or error dialog on the screen, some pop-up on the screen, you could say. Show dialog, just like show date picker or show modal bottom sheet before, wants a context value, which we set to this context object that's available in this state class. And it wants such a builder function, which should be a function that takes some context as an input and returns a widget as a value. And that widget will simply be the content of that pop-up dialog that will be shown. So here we get this context provided by Flutter automatically when it executes this builder method. And the widget I want to return here will be one of the built-in dialog widgets. Now there are a couple of built-in dialog widgets, and I'm interested in the alert dialog, which is a dialog styled and optimized for showing some alert message. The alert dialog widget then has a couple of parameters that can be set. For example, a title parameter, which wants another widget, where I'll use the text widget to give this pop-up window a title. For example, invalid input. And this can be converted to a constant text. I'll not convert the overall alert dialog because this would soon not be possible anyways. Because the title is not all that's added here, instead I also will add some content, which is the main text, the main content shown in the dialog. And here I'll create another text widget, though you could also use other widgets in here, don't get me wrong. But here I'll use some simple text and for example say, please make sure a valid title, amount, date, and category was entered. And now last but not least, we can also set the actions parameter along with many other parameters, as you can see, of course. But here it's the actions parameter which I want to set, which allows you to define a bunch of actions, typically buttons that should be displayed in that dialog, which, for example, allow the user to close the dialog, so to close this pop-up window. And here I'll add a simple text button as an action, where onPressed, of course, must be set to an anonymous function here, where I then actually want to close this dialog by again using navigator pop, as we did it before for the modal bottom sheet. And the pop method wants the context, in this case the context connected to this dialog, so this ctx value, which is passed into this function here automatically by Flutter. And besides setting onPressed, I of course also set my child here, the main content of this button, and here I'll set this to a text widget where I simply say OK and turn this into a constant text. And with that, we're showing this error dialog. Now, as a last step, I just also want to return after showing this dialog, because as mentioned before, whenever you return in a function, you make sure that no code thereafter in that function gets executed. So here I'm returning after calling show dialog, but still inside of this if statement, so that any code I add thereafter won't be executed if we made it into this if statement. Because if we make it in there, I just want to show this dialog and then do nothing else. I don't want to continue because soon, when we continue, we will use the entered data and create a new expense. And that of course should not happen if invalid data has been entered. So with all that out of the way, if we save this and force a reload, if I open this and I enter nothing, I get this error dialog, which I can close of course, but I get it whenever I try to submit invalid data. And that therefore of course works exactly as it should. Now as a next step, we can make sure that if valid data was entered, we use that data to update this list. And this is actually something which you can try on your own, because this is actually something which we basically already did in this course. Of course, not in this exact app, but the pattern, the approach you need here is one we already used before. But of course, in the next lecture, we'll also implement it together. So, did you succeed adding the expense that is created here to this list of expenses? Let's do it together now. And for this, we have to go to expenses Dart, because that's where we manage this list of expenses. And in here, we can add a new method that could be called add expense, because that's in the end what we want to do. And here in the end, I expect to get an expense value that should be of type expense. So using our custom class here as a type. And then here, I want to reach out to registered expenses and call the built-in add method, which is provided by Dart on all lists, to add a new item to the list. And of course here I want to add this expense as an item. Of course, that's not all I want to do though. Instead, this should be done inside of setState, like this, to make sure that the UI is updated so that the updated list is output here with help of expenses list. But that is all we have to do to add a new expense. Though of course at the moment, add expense is never executed. Now it should be executed from inside this new expense widget here. And to do that, we have to go to that widget and there add a new property. A new property that will actually store a function as a value, as we already did it in other course sections where you learned about this pattern of accepting functions as values in your own widgets. And this should be a function that returns nothing, but actually provides an expense value. And the property could be named onAddExpense, and I choose this naming pattern to make it clear that this in the end will contain a function that should be executed when a certain event occurs. In this case, when this form is submitted. Of course, here we then also have to accept this argument, this named parameter, and I'll use that same name by using this shortcut, and I'll require it, because this widget won't work if we don't provide this function. So with that, we got onAddExpense in our new expense widget class, but of course we need it inside of this new expense state class. We need it here inside of submit expense data after this if check down here. But as you also learned before in this course, you can get access to properties of the widget class that belongs to your state class by using the special widget property provided by Flutter. This is available in classes that extend the state class, as we're doing it here. And this simply gives you access to the connected widget class. And therefore we can also get access to this onAddExpense function property and execute it as a function here, because it is a function, and pass our expense to it. And for this, we create a new expense here, where we have to set title, amount, and so on. And the title, of course, is the value stored in title controller text. So this value here, that's what we assign here as a value for title. For the amount, we use this entered amount, which I'm extracting here. So this parsed text, which we validated. So at this point down there, we know that it's valid. Otherwise, we wouldn't have reached that code, because this return statement would have made sure that we don't get there if one of these values would have been invalid. The date is the selected date, of course. And here we get an error because Dart thinks that it could be null, but we know that it won't be null down there thanks to our validation. Hence, we can add an exclamation mark to tell Dart that we're sure that this won't be null. And the category here is, of course, the selected category. And with that, we're creating our expense, and we're passing that expense as a value to onAddExpense, and therefore indirectly to addExpense. And now we just need to make sure that this addExpense function is passed as a value to newExpense. So therefore here, we simply have to refer to addExpense. Now with that, we just have to remove const here. And this of course is also not a positional argument, but instead the value that should be set for onAddExpense. So this named onAddExpense parameter. And with that, we're passing this addExpense function as a value to newExpense so that it can be executed from inside there. And if we now save that all, and we try this and enter some values here, and select a date, and then also pick a value here and save this, we can close this. We'll have to make sure that it closes automatically soon, but we can close it manually for now. And we see our new expense here with all the data we entered in our input fields. Now with that, we're able to submit our data after validating it, and we can add a new expense. But of course, now as a next step, I want to make sure that this overlay actually closes after we submitted the valid data. And I want to make sure that this keyboard, which opens up as we tap into these input fields, doesn't possibly obscure any buttons or anything like that. So that's what we'll work on next. Now let's start by making sure that we actually close this overlay after a new expense was added. For that, here in newExpense.dart, after calling onAddExpense, inside of this submitExpense method still, we can use the good old navigator class, which we saw a couple of times already, and call the pop method and pass the context to it, this context property that's managed by Flutter in this state object here, to make sure that the overlay is closed, because of course we want to do that after adding a new expense. Now to make sure that this keyboard that opens up doesn't overlap our inputs, we have to go to the place where we open this modal bottom sheet and there set one new parameter, is scroll controlled, and set this to true. When you set this to true, the modal overlay will actually take the full available height and therefore ensure that of course now we don't overlap any inputs. Of course, you can see though that at the moment this also means that some content is obscured by some device features like the camera here. And to make sure that this is not the case, we can go back to the newExpense Dart file, and here where we add some padding around our form, we can switch from all to from LTRB, which simply allows us to set different spacings for different directions, left, top, right, and bottom, and set all these values to 16, except for the second one, which is the one to the top, as you can see here. And we could set this to 48, which should be enough no matter on which device you are working here. With that, things look good here. So this is now actually how we can make sure that we never obscure anything here. So this isn't looking too bad now. We can now add new expenses here with amount, date, category, and a title. Those expenses are then added to the list. Of course, the styling, as mentioned, isn't finalized yet. We'll take care about that soon. But before we do that, I want to make sure that we can also get rid of expenses by swiping them away. So by swiping from right to left. And at the moment, this is not possible, but it's such a common pattern that Flutter also helps a lot with implementing this pattern. So how can we make sure that these items can be swiped away? Well, for that, we can go to our expenses list, where we have this list view builder with our expense items. And Flutter gives us a special widget, which we can wrap around list items that should be swipeable, or that should be dismissible, removable to be precise. And the widget conveniently is named dismissible, like this. Now, dismissible wants a child, and that should be the list item that can be swiped away. So in my case, my expense item. But it then also needs a key. And I mentioned this key before. It was always this thing which we accepted here in our constructors and forwarded to the parent widget. And that was all we had to do with keys thus far. Now the good news is that in most cases, in most widgets, that is all you have to do with keys. There is a good reason why we haven't seen keys being used anywhere besides registering them here in our constructors. But there sometimes are scenarios where those keys are actually needed, because this key mechanism exists to make widgets uniquely identifiable. And I'll dive a bit deeper into all of that in a later section. But in the end here, where we should be able to swipe widgets away and then remove the data that's associated with a widget, a key is needed to allow Flutter to uniquely identify a widget and the data that's associated with it. And such a key can be created by using the built-in value key constructor function. This creates a key object which can be used as a value for this key parameter. And as mentioned, for most widgets, you don't need to set any keys. You don't need to worry about keys at all. But here, for the dismissible widget, a key is needed to make sure that the correct data will be deleted. So here we must create such a key, and the value key wants an input. In the end, it wants some input that can be used as a unique identification criteria or value for the widget to which the key is attached. And in this case here, we could simply take our expense, identified by index, as a value for value key. And that's all we have to do regarding that key. With that, if we add a comma for formatting and save this, and maybe force a reload, you will see that you can now swipe those list items. And this then removes them. Now, the connected data is actually not removed. Therefore, if I add a new item here real quick, a new expense, you will see that I get an error. Basically because we have a mismatch between what's showing on the screen and which data is still stored internally. But this is generally how you get this swiping effect. Now, of course, we must make sure that we also do something when we swiped a widget away. And for that, you can add the onDismissed parameter, which allows you to trigger a function whenever one widget has been swiped away, so when it has been dismissed. And here I, of course, want to trigger a function which then removes the associated data from my list of expenses. So I want to update the registered expenses list whenever I swiped one of my expense items away. Therefore, we should go to the expenses Dart file, to the expenses state, therefore, where we also added add expense before, and add another method here. And this other method could be called remove expense, because that is what I want to do here. And in the end here, I want to get the expense that should be removed. And we can then call set state here and reach out to the registered expenses and there call remove and pass the expense that should be removed as a value. And that should make sure that the expense is not just removed visually from the screen, but also internally from that list of expenses that we managed. Now in expenses list, we must accept this function as an input so that we can call this remove expense function from inside this widget. Therefore, as we did it multiple times before in this course already, we can add a new property which actually wants a function that returns nothing, but that takes an expense as an input. And that could be called onRemoveExpense here. And of course, this must be set when the expenses list widget is created. So we require it and then bind the named onRemoveExpense parameter to this property. And therefore, of course, down here, we can execute this function. However, we can't point at it like this, because onDismissed actually wants a function as a value that takes a so-called dismiss direction as an input, which simply is some information that tells us whether we swiped from left to right or right to left, so that you could, in theory, do different things depending on how the user swiped. Now here I'll simply set this to an anonymous function, therefore, where I get this direction, and I'm not really interested in the direction, but I still have to accept it here. And then I can call onRemoveExpense, and then pass my expense as a value to onRemoveExpense, and basically ignore this direction. Well, and with that, we just have to make sure that removeExpense is also passed as a value to expenses list. So therefore here, we now have to set this newly added onRemoveExpense named parameter and set it to a pointer that points at removeExpense. Like this. And with that, if you save that and force a reload, if I now swipe this away, it's still gone, but now you will see that as I add a new expense here, I don't get that error because now the UI is in line with the internally managed data. And that's how easy it is to make items in a list dismissible. So we can now also remove items. There are two things related to that I want to add to this app now. For one, it would be nice to have some fallback message here if we have no expenses at all. In addition, I want to show a little info message at the bottom whenever we did remove an item, which also offers us a button which we can click to bring back that expense item, in case we swiped accidentally. Now let's start with the easier thing, with showing that fallback message instead of showing that list, which would be empty. To do that, we can use a ternary expression, or to mix things up, add a new variable here, which stores a widget, which we could name main content or anything like this. And initially here, we could use the center widget to show some centered text where we say no expenses found. Start adding some. Something like this. And this can be a const value here. And we want to replace that if we do have expenses. So here we can add a if check and check if registered expenses is not empty, another utility property offered by Dart, which we can use on lists to find out whether a list is not empty. And if registered expenses is not empty, we want to overwrite main content and store a different value in that variable instead. And that different value should be this expenses list here. So I will grab that list and cut it and store that in main content instead. And now it's of course main content that should be output here as a child in this column. Therefore here I see no expenses found, but if I add a new expense here, like $16.99, and maybe this is travel, we see that instead. So this works. But now let's work on that message that should be shown if we dismiss an expense. To show a message after deleting an expense, it sounds like it would be a good idea to go to this removeExpense method, because that is where we do remove expenses. And indeed it is here, after calling remove, where I do want to show this info message. And we can show such a message by using another feature offered by Flutter. Besides all these utility show functions which Flutter offers here, it also offers a special object which you can use for showing or hiding certain UI elements. And here, that would be the scaffold messenger utility object which we want to use. This scaffold messenger object has an auth method which we must execute, which wants a context value, which, as you learned, is available in this class, which is based on the state class. Now this then gives us an instance of this scaffold messenger, and this scaffold messenger thing offers us various utility functions and methods that help us with controlling the user interface and showing certain things on that interface. Most importantly, we can call show snack bar to show a so-called snack bar, which you might have not heard before, but which in the end is just an info message which is shown on the screen. And show snack bar wants a snack bar value, and this value can be created by using the built-in snack bar class and instantiating this class here. And snack bar then needs at least a content which must be set to a widget. And in most cases, this will probably be some plain text. So here, for example, we could say expense deleted, because that is what we did. And this can be set to be const. But there is more that can be configured about that snack bar. For example, it also has a duration parameter that can be set and that wants a duration value, a value of type duration, which can be created with the built-in duration constructor function, so the built-in duration class. And this then has various parameters that can be set to define a duration. For example, we can set it to 3 seconds here. And this can also be turned into a constant value. And we can also add an action to our snack bar. So not actions, but one single action, and this must be of type snack bar action, which is created by using the special snack bar action constructor, so the snack bar action class. And this then has also some configuration items, some parameters we can set, like for example the label, which does not want a widget, but a plain string. For example, undo, so that we have a button on that info message that allows us to bring back that deleted expense. And we then also have to add the onPressed parameter to define the function that should be executed if this undo button is pressed on this snack bar. And in here, I then want to call setState to update the UI and change registered expenses. And instead of removing something, here I want to add something again. However, actually not with the add method, but instead with the insert method, which also adds an item to a list, but we add an item to a list at a specific position, because I of course want to bring back that expense that we removed in exactly the same place where it was before. Now for that, we first of all need to find out where this expense was by getting the expense index, because insert wants the index where the element should be added and then the element that should be added. So we first of all need to find out which index this expense that we removed had, and for that, of course, before removing it, we need to get that index. We can get this by reaching out to registered expenses, and then there we have an index of method provided by Dart, to which we pass a value, and as a result we'll get the position of that value, the index of that value in that list. So it's then this expense index, which is passed as a first value to insert. And the second value is that expense which we deleted before. It was removed from the list. We can still access it down here though, and it will then be brought back into the list. And that's how we can display such an info message with such an undo button. If we now save that and force a reload to bring back those dummy items, you see that if I swipe them away, I get this info message at the bottom, and it disappears after 3 seconds, but I can also press the undo button to bring back the item. And if I force a reload again, so that I have both items back, You will also see that if I remove Flutter course, which is the first item here, and I bring back that item, it's brought back in first place, because that index was used to insert it in the right place. I can also remove both items, and in that case we might want to make sure that the info message that belonged to the item that was just removed is immediately cleared, so is also removed from the screen, and we show the next info message instead. Because at the moment, as you can see, if I remove both items, we get the first info message, and only after this one disappears, the next one appears. This might not be what we want, and we can make sure that we clear all existing info messages that we might have on the screen by using scaffold messenger of context, and there we can call clear snack bars, which removes any snack bars, so any info messages we might still have on the screen. With that, if we saved it, if I remove both, you see the old message is immediately removed and the new one is shown as I remove multiple items. So that's how we can show those info messages and how we can bring back items if we accidentally removed them. Now at this point, from a feature point of view, this app is almost done. Sure, the chart is still missing, but we can manage our expenses here. We can add expenses and delete expenses. We can undo such a deletion process if we want to. So that's looking good. And of course, we'll get back to the chart. But before we do that, it's finally time to come back to styling this app and to take a closer look at Flutter's theming mechanism, which you may use for styling your apps. Because of course, whilst this app doesn't look super ugly, it's also not really that appealing visually. And of course, what we could do to make it more appealing is we could style the individual parts manually, just as we did it in other sections in this course. We could, for example, set up a linear gradient for the background of our scaffold widget, as we did it in this quiz app we built earlier in the course. And we could use techniques like this to style this app here, this expense tracker app, if we wanted to. And of course, there's nothing wrong with this approach, but it would also be nice if we had one central place in which we could set up certain styles, and those would then automatically get applied to certain widgets, or could at least easily be referenced from inside our different widgets, so that we, for example, don't have to copy and paste color definitions across different parts of our app. And this can be achieved with Flutter's theming system, which we can set up here in main Dart in our material app widget. Because this material app widget, which is this root entry point to our app, so to say, this root widget that contains all our other widgets in the end, this material app widget is the widget you use for setting up your app's theme. Because I mentioned before that this app widget does a lot of behind the things stuff, but it also gives you some key configuration settings that you can make here that influence your entire app. And the theme is one of those settings. And indeed, at this point here, I already have a theme set up. I got theme data set to use Material 3 to make sure that my app here uses this Material 3 look. Now, this might not be necessary anymore at the point of time you're viewing this video, because Material 3 might be the default by then, but this theme parameter that can be set on this Material app will be useful nonetheless, because setting up a theme is not just about switching between the Material 3 or Material 2 looks. But instead you can use this theming mechanism to control in detail which color different widgets in your app will have, and which colors you want to be able to use in your app, and which text styles you want to be able to use, and so on. So how can you then customize this theme? Customizing your application's theme involves setting this theme parameter here on the Material app, as we're already doing it. And theme wants a theme data object, which can be created with this theme data class provided by Flutter. Now, when instantiating this theme data class, you got many parameters that you can set to fine-tune your app's theme. And this can be super overwhelming, and I will also say that Flutter's theming system, whilst being quite powerful and flexible, also evolved a lot over time, and therefore this theme data class here also allows you to set a lot of parameters which still work but shouldn't be used anymore because they might be removed in the future and there are better ways of configuring your theme. It's also worth pointing out that if you create a theme data object like this by instantiating theme data and then passing some configuration between those parentheses, you're actually telling Flutter that you're setting up the entire theme from scratch. Which means that theoretically, you really should configure all these aspects that make up your application. You should configure all text styles you could possibly use. You should configure all other styles that might be used by any widgets in your app. And whilst this, of course, can make sense for certain apps, it also means a lot of extra work because you might be happy with some default theme styles that Flutter applies otherwise. Now, of course, you could argue that this app here, by default, doesn't look that horrible. And that is correct, but you'll see a difference if I switch to a different way of setting up my theme, a way which I would actually recommend using. Instead of creating your theme data like this, it's better if you don't pass anything to this constructor here, and you instead call copy with, and then to copy with, you pass your settings, like for example in my case here, use material 3 true. If you do that and you force a reload, at least for me, I always have to force a reload to make these theme settings have an effect on the running app. If you do that, you will see that it now looks slightly different. It looks slightly different. For example, this text in the title here looks different, and I would argue looks a bit better. Because now we're actually preserving some better default styles that are applied by default by Flutter, and we can now override selected styles with that copy with method. So instead of setting up an entire theme from scratch and having to style everything from scratch, we're now using some default themes set up by Flutter, and we're only overriding selected styles or selected aspects of that theme, you could say. For example, we could now also target another parameter here in this copy with method, which we're calling, and set the scaffold background color to any color of our choice. Maybe not red, I'll just use this as a starting point to pick a color, but then we could go for something like this, like a light purplish color. We'll change this later anyways, but we could do that, force those changes to be applied, and now you would see this background. Of course, this doesn't look great yet, but this is how you can now overwrite individual parts of the overall theme. And here you can see that it's now in one central place where I can make certain adjustments, like this scaffold background color. And it will then automatically apply to all the widgets that are interested in that setting. In this case, the scaffold widget. And if I would have an app with multiple screens, so with multiple instances of the scaffold widget, all those screens would use this color. So that's how theming generally works and how you generally, in most cases, want to apply your changes to a theme. Instead of setting up an entire theme from scratch, it's often better to copy an existing theme and then just style individual aspects of that theme. Okay, so now that we have a first idea of how the theming system generally works and how we might want to adjust the theme, the question of course is, how should we now adjust the theme and which parameters should you set here? Well, in general, as always, it is a good idea to simply play around with different parameters here, but there is at least one thing you should know before you start playing around with that. When it comes to setting up colors, there are many different parameters you can target here. And you have to understand that this copy with method allows you to set up some base colors like accent color or primary color, which will then be used by multiple widgets that are built into Flutter, and you can also use these colors in your own widgets, as I will show you later. But besides setting some general colors like this, you can also set individual colors, like the scaffold background color, or you can set up entire sub-themes, you could say, like the elevated button theme, which requires a separate theme data object, which then allows you to set up some button-specific styles. And this can of course all be overwhelming, which is why we will set up these things step by step. But when it comes to setting up colors, there is a certain approach which I recommend using. And that is the usage of a color scheme. And that's what I meant before. The theming system in Flutter saw a lot of changes over the years. And color scheme is now not a new approach, but arguably the easiest approach of applying some colors to many widgets without having to manually set a bunch of colors individually. Instead, with color scheme, the idea is that you define one color scheme and Flutter then infers colors, different shades of colors to be precise, for different widgets. And for that, I'll first of all create such a color scheme, and I'll do that outside of this theme data constructor function to keep my code a bit more organized and structured. So here I'll create a new variable, and I'll name it K color scheme, and starting with K is just a convention you might want to use in Flutter, that you set up global variables with the starting character K. It's not something you have to do, but it is something you'll see quite a lot, especially for theme-related variables in other projects, so that's why I'll use it here as well. And the idea here simply is that this variable now contains a color scheme which we can use down there for setting up our theme. And a color scheme can be created by using Flutter's color scheme class, and whilst you could also create that from scratch, which again would require you to set a lot of colors manually, color scheme also gives you a from seed method or a from seed constructor function, which I recommend using because that is actually the constructor function that will then automatically create a color scheme with different shades of colors based on one base color, one seed color that you set up. And here I'll create a color manually with color from ARGB, and here I picked a color in advance where my alpha channel has a value of 255, red has 96, the green channel has 59, and blue has a value of 181. And this is a constant value, so we can add const here. And with that color scheme defined here, we can use that as a value down there in our theme. And if we do that, and again we enforce those changes, now you don't see a lot of changes here, but you see them if I, for example, open that modal. Here you see the buttons now have this purple color, and the background also has a light purple shade at least. Same is true for these cards here, which have a light purple background. And of course, we're also not done yet. Because now with that color scheme set up, you can fine-tune your theme. Besides setting up the color scheme when setting up the theme, you can now also override selected parts of the theme based on your color scheme though. For example, you can set up an app bar theme here and create an app bar theme object. Again, best done by creating an object and then using copy with, so that you get some default app bar theme settings by Flutter, and you then just override selected settings. And here you can then, for example, override the background color of the app bar and set this to a color from your color scheme. So reference your color scheme here, but now you get different properties on that scheme object that were inferred and set automatically by Flutter based on your seed color. For example, here I'll choose on primary container as a background color for my app bar. And I can only encourage you to try out different colors that were inferred here to see the difference, but I'll go for on primary container. And I'll also set a foreground color for my app bar theme, and also set that based on my color scheme, and here I'll choose the primary container. so that I pick these two colors from my color scheme that is based on this seed color to fine-tune my app bar theme. And there are more things you could set on that app bar theme. For example, that the title should always be centered, or that there should be some drop shadow behind it. These are all things you can set, and again, definitely play around with these settings. But since we're using copy with, we don't have to set these settings. Instead, we're using the default settings and we're just overriding background color and foreground color. And here we can then actually also use const. And with that, if we now save this, you see that I have a totally different look for my app bar here because of these selective overrides which I made in my theme object. So creating a color scheme and using that as a starting point for your copied theme, and then overriding some selected aspects of your theme is the way to go. Now, there are of course more things that you can override. For example, we could also apply a card theme, which will affect all card widgets. And in case you forgot, the card widget is the widget we're using for our expense item here. So for these items in our list of expenses here, they use this built-in card widget, and we can override the default styling of the card widget, which is based on our color scheme, but which might still not be the styling we want, with help of this card theme. This wants a card theme object, just as app bar theme wants an app bar theme object, and just as with the app bar, here I will also copy this. And that's basically always the approach you want to use with theming. You want to copy an existing theme. For the card theme here, we can, for example, target the color parameter alongside other parameters that you could use to fine-tune the look of your cards. And we could set the color here to our color scheme again. And now here, select the secondary container, for example, which is another color that was inferred by Flutter. In addition, we could set the margin to an edge insets object, just as you do it if you configure it right on the widget when you use it. But here you could set up a margin for all the cards used anywhere in your app, if you had a certain default margin that you always want to apply. And you could, for example, here set a base margin that will always be used for all cards of 16. And now here we can also use const and also use const here. And again, save this and enforce this. And now the cards would look like this. And this is actually not bad, but it's a little bit too much spacing between those items for me. Hence, I will actually switch from edge insets all here to edge insets symmetric and keep the 16 pixels horizontally, but vertically I'll switch to 8 to have a little bit less spacing vertically between my different cards. Yeah, I think that looks better. Now, I also showed you before that you can, for example, set up some default button styles by targeting the elevated button theme. And here we want to create an elevated button theme data object. And on this object, right now at least, there is no copy with method. Instead here, we always have to create a new object, but this object takes only one parameter, the style parameter, which wants a button style object. And here we could create such a style object manually with button style, but then we would again create it from the ground up, which can sometimes be what you want, to have full control over how the button looks. But often the better approach is to use elevated button style from, which again uses Flutter's default styling and then allows you to override some selected styles. Unfortunately, we have inconsistencies like this in the theming system, where sometimes it's copy with and sometimes it's an approach like this. But that's why I'm showing this to you for some of the most important widgets you'll work with. And as always, the official documentation and also simply Google is your friend when it comes to finding out how a specific widget is best themed. Here for buttons, I recommend using style from on the elevated button in this case. And now we can again target some individual style settings for all the elevated buttons in the entire app, because that's always the idea behind theming. You always set up styles for all widgets in the app. And here we could, for example, change the background color of our elevated buttons and set this to K color scheme primary container in my case here. And if I do that and we enforce these changes, you see that now my elevated button here has a more visible background color. Not super prominent, but a bit more visible, which to me looks better than the almost white background color it had before. Now I'm almost done with setting up the theme I want to use for this app here, but there's one last setting I also want to apply here before we then take a look at some other theme-related topics. And the last parameter I want to target here in my general main theme data object is the text theme parameter. Because of course in our application we also have many places where we output text, like for example here in the title. And of course the default text styles might work for you, but you can of course also fine-tune those. And the best way of fine-tuning them on a global level is to set the text theme parameter in your theme data object. Now this wants a text theme object, and of course, as always, you could create one from the ground up and then target the different kinds of text you might be using in your app manually here. But I personally prefer creating a theme data object here again, and then on that object accessing the text theme. And then on that text theme here, you can again call copy with. This ensures that you're overriding the text theme that belongs to your theme data object here. Now in copy with, you can then target different parameters, and these parameters represent different kinds of texts that are used in different parts of your application. For example, the text used here in the app bar is the title large text. Now, how do I know that? Well, the official documentation, of course, helps with that. But in addition to that, you can also simply try out setting those different text styles and see which texts change in your application. Title large, as mentioned, should allow us to change the text style of all the places where main titles are presented, like in this app bar. And now to change the text style, you have to set a text style object as a value for title large. And of course here you can create one from scratch. Alternatively, you could also access themedata.texttheme.titleLarge and then use copy with to just override selected parts of the text style of your main title. It depends on how much you want to change. Here I'll create a brand new text style, and then we could, for example, change the font weight and change it to font weight normal if we wanted to. We can of course also set the text color, and here I'll use my color scheme and then use on secondary color as a default color here for me, and maybe set the font size to 14. If we do all that and enforce those changes, you see the title now got smaller and is not bold anymore. Now regarding the color, you of course have to be careful because we're also setting a foreground color in our app bar theme, which typically should override any text color you set here. You can prove that if you set it to a color like red, which would be clearly visible. Even though I set it to red here, it's not red here, because I have that separate foreground color in my app bar theme. But of course, other places where I use this title large in my application might have a red text color. So here I'll switch back to the other text color, which I actually want to use, but it is important to understand how that works. And with that, I have set up a couple of styles and a couple of theme settings that are automatically picked up by various widgets in this app, as you can tell. And again, definitely feel free to play around with all these settings to get a better feeling for how you can influence the general look of your application. But this is also not all you can do with theming. You cannot just change the general look of your application or of the built-in widgets. Instead, you can also reference settings you made here in your theme data setup from inside your custom widgets to pick up certain styles and override styles in your own widgets based on your general style setup. And that's what we'll do next. So we got our theme set up, and this is of course very useful because it means that we don't have to manually overwrite all these stylings in different parts of our app. But sometimes you of course wanna overwrite certain styles in your app, but you also at the same time might want to use, for example, colors from your main theme. And how could you do that then? Well, let's for example start in expense item. Here, in expense item, we might want to change the look of our expense title. And for that, of course, we can add the style parameter to this text widget as we did it before in this course as well. And we could manually create a text style object here to set up the styling of the text. But now that we learned about theming, we can also reach out to our theme stylings and apply those to this text here. And to do that, we can use the theme class built into Flutter, which has an of method, which needs the context as a value. And that is a pattern we saw before with the scaffold messenger. There we also had such an of method to basically reach out to this metadata context object managed by Flutter. The theme class needs to do the same thing. It is constructed by connecting it to this context object. And this connection is needed because through that context object, Flutter gets access to our theme settings basically. And now on that theme class or on that theme object that was created here, we can, for example, access the text theme property to get access to all the text themes that we set up and all the default text themes that were set up automatically that we didn't overwrite. And then, for example, reach out to title large. And this will then apply the text styles that are set up for title large, so either the default text styles or, as in this case, our own text style which we set up for title large. And this text style will now be applied to this expense title. And you can see this more clearly if we go back to the main Dart file and we change the font weight of our title large here from normal to bold and maybe increase the font size to 16. If we do that and force a reload, you now see that this title here in our expense item clearly is bold and has a different look. Please also note that it has a different color than we have here in the app bar, because of course, as mentioned before, in the app bar we're setting a separate foreground color, whereas here we're setting a different general color for title large. And it's this color here, which is now picked up by expense item, as you can again see if I change this back to colors red. Briefly, of course, only, but if I do that, you see that now the title is indeed red. So that's how you can use some settings you set up in your general theme in your own widgets. And of course, here I'm switching back to the actual color I want to use. So that's how we can pick up theme settings. Now, of course, here I also want to make sure that this title is actually pushed all the way to the left here. And to achieve this, I don't need to do any theming. Instead, I can simply go to this column that contains my text here and set the cross-axis alignment, which for a column is the horizontal axis, to cross-axis alignment start. And this will make sure that all the column items are moved to the start of the column horizontally, so to the left in this case. So that's how we can reach out to our theme to use certain values from that theme. But we're not limited to using text settings. For example, in my expenses list, I also want to add a background color to this dismissible item, so that as we swipe an item away, we actually have a little background effect that indicates to us that the item will be deleted. And this can be achieved by going to the dismissible widget and setting the background property or parameter there. Now the background parameter wants a widget. And for that here, we could use the built-in container widget, because this widget allows us to set a lot of different parameters, including the color, which is actually the background color of the container. As you see here, the color it paints behind a possible child widget you might include in the container, and that therefore allows us to set up a background color. And this, of course, wants a color. Now, as before in this course, we could create a color manually here, but now that we learned about theming, we can also pick a color with theme off from our theme. And that allows us to pick a color that's more in line with our general color scheme. And to do that, we can access theme of and then .color scheme to get hold of that color scheme we set up in our main Dart file. Remember, we created this color scheme with one seed color. Now, as mentioned, this behind the scenes creates a lot of different shades and variations of that color for different aspects of the app. And we can now use those shades and variants here to access the error color, which is one of the automatically generated variations of our seed color for error scenarios. If I do this and I save everything, you will see that as I swipe this item here, I get this red background container coming in, indicating to me that this is going to be deleted. Of course, here we then also could apply some fine-tuning and, for example, add a margin with edge insets and then use symmetric to add some horizontal margin of 16. So that with that, if I force a reload, this container actually starts where the list item also starts. But of course, here we would have the problem that if we ever change the margin of the list item, we have to change it here as well. And you might remember that in main Dart, I actually set the margin of the card theme here to horizontal 16. So that's actually where this margin here is coming from. So therefore, since this is defined in our theme in this application here, we of course can get this margin from our theme by again using theme of and then getting the card theme and there the margin. Or if I only want to apply the horizontal margin, as it's the case here, I still create an edge insets object with symmetric to set my horizontal margin, but this value is then derived from my theme by accessing cardtheme.margin.horizontal. And here I'm getting an error that in the end margin could theoretically be null because I might not have set it up in my theme, but here I know that it was set up, hence I can add an exclamation mark to get rid of this error. And with that I get the same effect as before, but now it's coming from my actual theme. And these are all things you can do. Now, being able to use theme data for fine-tuning certain widgets is a very useful feature. And it does not stop at simply using values defined in the theme. Instead, you can also extend or change those values. For example, for a color like error or any other color, you can also use one of the built-in methods Flutter offers on colors, like with opacity, to make this color slightly transparent. For example, by adding an opacity of 0.75. If you do that, you will see that now this red tone is slightly transparent. Now, you might or might not want this, but it is important to understand that you can adjust those theme-controlled values in the places where you're using them. For example, in expense item, we're also not limited to using the title theme like this. We could also use copy with here to use our general title large theme settings, but then override them with specific settings that we want to use specifically here in this widget. So which will not be changed in the general theme, but which will be adjusted in this widget, whilst still basing our general style on the theme settings. Now here I actually got no adjustments I want to make, but it is important to be aware of these fine-tuning possibilities. So at this point, we had a quite detailed look at theming. There's just one last theme-related topic I also want to discuss here. And that would be how you can apply a dark theme, or how you can allow the user to switch between a dark and a light theme. Because at the moment we have this light theme with a lot of white in it, and some users might prefer dark mode. Some users might even set dark mode as their intended default in the device settings. Like for example here on Android, where I can search for dark and turn on dark theme. Now my Android phone is in dark mode, but of course my app doesn't care. That's why you might want to provide an alternative dark theme. And for that, to do that, we could create a second color scheme the dark color scheme. And here, again, we can do this with color scheme from seed, but the seed color I want to use here for my dark mode is now a color, which I also picked in advance, which uses the from ARGB constructor and then values of 255, 599, 125. Of course, again, you can play around with different colors. That's just one color I picked here. And with that dark color scheme set up, we can now also set a second theme on that material app besides this theme. This is our light mode theme, but we can also now add a dark theme parameter to material app. And this dark theme parameter can now be used to configure, well, a theme for dark mode. For this, we can again use theme data, and now conveniently, there actually is a dark constructor function which we can use to get a lot of default dark mode settings and configurations so that we don't have to adjust everything manually to get dark mode to work. So we can use this dark theme data constructor function instead. And then here we can again use copy with and apply material 3 by setting this to true. But then here, of course, we can also set our color scheme and set this to the dark color scheme we just created. And with that, we're creating a dark theme here, which can be used as an alternative to the main theme. Of course, that just brings up the question which theme will be used. And this can be controlled with yet another parameter you can set on the material app. And that would be the theme mode parameter. Theme mode wants a theme mode object, and here you can actually choose from multiple predefined theme mode values. You can, for example, force the app to always run in dark mode or always run in light mode, ignoring what the user might have set up in their system settings. But you can also use theme mode system to take a look at the system settings chosen by a user and apply the appropriate theme. And this is actually the default, so you don't need to set this yourself, but it is worth knowing about this setting. Well, and with that, if you force a reload and you put your phone into dark mode, you should see that dark mode. But here I'm now actually getting an error. And I'm getting an error now because in one of my widgets, in the expenses list widget to be precise, I'm actually referring to the margin setting on my card theme, and I'm telling Dart that this will not be null, when actually now in dark mode, it is null. It is null because in dark mode, I'm not setting that card theme. That is why you should also be careful with using this exclamation mark operator. You instead might want to check whether this is null or not, and then set different horizontal values based on the check result. Here I'll solve the issue by simply copying my card theme from the light theme to the dark theme here, so that I am setting these margins again. And with that, if I force a reload, the error goes away, and you can see I have this dark background color on my scaffold now. You also see that the other styles don't look that great though. And part of the reason for that is that the color scheme we're generating here uses a specific seed color, but the shades and variants that are generated by from seed are actually optimized for light mode. We have to tell our color scheme that the different shades and variants that are generated should be optimized for dark mode. And this can be done by setting the brightness parameter in this from seed constructor function and setting this to brightness dark. And this tells Flutter that this is a color scheme for a dark brightness, so for dark mode in the end. If you now force a reload, this already looks much better because we have this dark app bar, for example. But that being said, the card background color doesn't look that great though. And the reason for that simply is that in the dark theme, I'm currently still using the normal color scheme which I created first for getting the secondary container color of the card theme. And that's the wrong color scheme. Here we want to use the newly created dark color scheme which takes our dark colors into account. If we save it with that, these expenses already look much better. Now, of course, the buttons here in this modal maybe also don't look that great. And to change those, we can again copy the elevated button theme settings from the light theme, the default theme, and add them to the dark theme. But here, of course, we now also want to use the dark color scheme, which we created, and see how that looks like if we take primary container from there for our dark color buttons. With that, this already looks a bit nicer. Maybe the foreground color should be changed though. And therefore here for the dark theme, for the elevated button theme, we could also add foreground color and set this to K dark color scheme and then on primary container. Because the primary container is the background color, for the foreground color, which colors the content inside of that button, on primary container might make a lot of sense if you consider the name of it, primary container and on primary container. So with that, if we save this, yeah, that definitely looks better. We could also change the color of this text button, but I'm happy with that. And with that, we now also added a dark theme. And indeed, we added it such that the device settings are taken into account. If a user switches back from dark to light mode, our app adjusts accordingly. So at this point, we're almost done with this app. And this was another long course module, but again, with many important new concepts and of course, a lot of chances to repeat concepts we learned about before. Now, the missing piece for this app here is of course the chart. And to build this chart here, I first of all want to go to my expense model and add a new class, a new data model to this file. And that will be the expense bucket class. Because for building this chart, we need multiple buckets, one for every category, so that we can sum up all the expenses that belong to one category and display them in the chart. So for that, I'm creating a separate class that will hold that summed up data. And this class here, which defines a group of expenses in the end, needs two main properties. It needs a category property, which is of type category, so which uses our own category enum type here. And in addition to that, I also want to have a list of expenses, because such a bucket, as mentioned, will include multiple expenses. That's the idea behind this class. Therefore, of course, we then can add our constructor expense bucket, where we set this category and this expenses, and both should also be required, like this. Now, in addition to setting up those properties to store all these expenses, I also want to add a getter to this class here, which will return a double value, so a number with decimal points. And I'll name this total expenses. And this is simply a utility getter, you could say, which I'm adding, which sums up all the expenses we have in here, so that we can conveniently get the total expenses from a bucket. And keep in mind, we'll have one bucket per category. Now, to build that sum, I'll create a helper variable, sum here, which starts at 0. And I want to return this sum in the end. But in between these steps, I want to sum up all the expenses. And this can be done with a for loop, though I'll use a new version of that for loop, a variant of that for loop, which we haven't seen before. Instead of creating a for loop where we create a helper variable I and we then keep on looping as long as I is smaller than expenses length, for example, and we increment I by 1 after every iteration, instead of doing that, which we could also do to get hold of the individual expenses, I'll use a variation of that for loop, which is perfect for going through all the elements in a list. You can use this syntax where you create a helper variable, which for every loop iteration is final because it will be recreated after every iteration. And here I'll create a helper variable expense, and then we can use the special in keyword to simply tell Dart that we want to go through all the items in this list, so in expenses. And in every iteration, a new item will be picked and will be stored in a newly created final variable called expense. And then, therefore, inside of that loop body, so between these curly braces, we have access to that single expense. And this simply is an alternative which is perfect for going through the items in a list, since it is a bit shorter and maybe easier to understand than manually managing a helper variable I and using that as an index. Which you could of course also do though. But here we can loop through all the expenses in our expenses list like this, and then simply add the expense amount to the sum by setting sum equal to sum plus expense dot amount. And this can actually be shortened and can instead be written like this, which is the equivalent to setting it like this. This is simply shorter and tells Dart that you want to set sum equal to sum plus the expense amount. And this is therefore how we can define such a getter that sums up all the expenses in this expense list and returns a total sum as a number. And we'll need this helper for the chart because in the chart, of course, the different bars for the different expense buckets, so for the different categories, should be displayed in relation to each other. And for that, of course, we need to know the total expense of every bucket so that we can adjust the chart bar heights. Now, adding this getter to expense bucket is one important step I want to take before we start creating the actual chart. The other thing I want to do here, I want to add my own alternative named constructor function, which can be done by repeating the name of the class, expense bucket, and then adding a dot right after it inside here of the class definition, and then adding the name of the extra constructor function you want to add to this class. Like in my case here, for category. That's the extra name I want to use. And this is how you can add additional constructor functions to your classes. And this is of course a feature we used from time to time in this course, for example here on Edge Insets Symmetric, where we create such an Edge Insets object by using the alternative symmetric constructor function. This here is how you can define your own alternative constructor functions, alternatives to the default constructor function. So what's the idea behind this alternative then? Well, my idea here is that I do get a list of expenses here, which could be named all expenses here. So this is simply a parameter accepted by this constructor function. So we expect to get a list of all expenses here from all categories. And I also want to get a second argument, which sets the category, which is one of the properties I do want to set here. And now the idea behind this extra constructor function is that we add some logic to this constructor function to go through all the expenses we got and then filter out the ones that belong to this category so that we can set the expenses for this expense bucket, which is tied to one specific category, to a list of expenses that only are for that category. So this is simply a utility constructor function that takes care of filtering out the expenses that belong to a specific category. Now, to set this expenses property to the expenses that have this category at the point of time this constructor function is called, we have to add a so-called initializer list by adding a colon after our constructor function parameters here, so after this closing parenthesis. And then here, you can set expenses, so this property here, equal to all expenses, so this list of expenses we're getting here, and then filtered for the expenses with this category. And this can be done with help of the built-in where method. Now this is a method provided by Dart, which is available on all lists, and where is simply a method that allows you to filter a list. It takes a function as an argument, so you pass a function here as an argument to where, here an anonymous function using this arrow notation, and then you automatically get your individual list items as input. So here I get a single expense, since this function is executed on all the expense items in all expenses. So every time it executes, I get one single expense. And here we have to return true if we want to keep that expense in the filtered list, or false if we want to get rid of it. And here, of course, I don't want to hard code true or false. Instead, I want to derive true or false dynamically by checking whether the expense I'm currently evaluating here has a category that's equal to this category here. So to the category property of that class. So if the expense I'm currently taking a look at has the category I want to set for this expense bucket, I want to keep that expense in that list of expenses that is stored in this bucket. Otherwise, it should be dropped. That's what we're saying here. And now we just have to make sure that we convert this back to a list. And here we have to check with a double equal sign, because a single equal sign tries to assign a value, which is not what we're doing here. With a double equal sign, we check for equality, which is what we want to do here. And with that, we got this utility constructor function in place, which we will soon use to create the different buckets that are represented by chart bars in our chart. Now, with this newly added expense bucket class here, we're now ready to work on the actual chart. And for that, in the widgets folder, in the lib folder, I'll add a chart subfolder, and I prepared two new widget files, which you'll find attached to this lecture, chart.dart and chart.bar.dart. And you should download both and place them in your chart folder in the widgets folder. Now, these files are responsible for creating a chart widget, which then contains multiple chart bars. And I'll walk you through these widgets in just a second. You should make sure that in chart.dart, these imports work for you, so that you're using your project name here and that you have the same folder names I'm using, widgets, models, chart, and so on. Of course, you also must use the same file names. And you should make sure that if you named your model differently, the expense bucket or the expense model, you update those names here in chart.dart. After all, errors should be highlighted if you have any in this file. If you followed along with the same conventions I used throughout this section though, this file should work fine for you. And the same should be true for chart.bar.dart. Attached, you also find a link to my complete current project snapshot, so that you can also compare the other code files to yours in case you're facing any errors with those newly added files. But what do these files do now? Well, first of all, let's use them. In expenses start, we want to replace this chart placeholder here with the new chart widget that we just added. So for this, we have to import chart.dart from the widgets folder, and they are from the newly added chart folder. So that import here must be added. And with that import added, we can use the chart widget here in this column. And we must set the named expenses parameter to our registered expenses here. So to all our expenses. Because in the chart.dart file, we're then actually getting those expenses and storing these expenses in a property. But I got a getter, a helper getter, which then creates these expense buckets. Using this newly added expense bucket class on which we worked over the last lectures, to create different buckets for different categories, so that we have these 4 buckets that are needed to display these 4 bars, or up to 4 bars, in the chart. Because if we save everything now and force a reload, we should see this chart here. And if we switch to dark mode, which we of course also can do, this chart should also look good in dark mode. Yeah. So this also looks quite nice. But how is this being displayed? Well, we got these buckets here, as mentioned, which are generated in this getter, and this getter is in the end used down there in this widget tree to go through all these buckets and create these chart bars. Now this code here might look strange, though I have mentioned it before in this course already, but it's still worth repeating what this code does. As I annotated here, it's an alternative to the built-in map method. And you can use this code here in your widget tree if you're inside of a list of widgets. So if you're in a place where a list of widgets is required, like here for the children of a row. Then you can use this for loop here with a syntax that's similar to what I showed you in this expense bucket class in this getter here, where we also had such a for in loop. But if you're using it in a widget or in a place where a list of widgets is expected, you actually have no curly braces thereafter. Instead, you just have this for in loop like this to loop through a bunch of pieces of data. And then right below this for loop syntax here, you have the widget that should be created for every item in that list of data. So here I'm creating one chart bar widget for every bucket in my list of buckets. And buckets, keep in mind, is this getter here, where I return this list of for expense bucket instances. So I'm looping through these buckets here, and I'm creating one chart bar in this list that belongs to this row for every bucket. Now the chart bar has one fill parameter, which is set to a number. And the number is based on the total expenses in a bucket. So that is this total expenses getter being used here. So the sum of all the expenses that belong to a certain category divided by max total expenses. And max total expenses is actually a getter that belongs to this chart widget. In this getter, I go through all my buckets with another for in loop, and then I simply determine the highest total expense from all these buckets, so from all these 4 buckets in this case here. I do that here by taking a look at each bucket's total expenses, so the sum of all the expenses in that bucket, and if that's higher than the highest total expense I got up to this point, starting at 0, I take that bucket's total expenses as the highest amount of total expenses. And I'm doing this because in the end, in the chart, the goal of course is to put these different bars in relation to each other. And the bucket with the highest expense should have the tallest chart bar, and the other bucket's chart bars should be drawn in relation to that. So that's what I'm doing here with this getter. And I'm simply passing the division of the total expenses of a single bucket by the maximum total expense across all buckets to chart bar, because in chart bar we're using this fill parameter and this fill property here to set our chart bar height. And I'm doing this with a new widget, the fractionally sized box, which simply does not take a fixed height in pixels, but a height factor instead, which simply is a number between 0 and 1, and 1 means that it takes 100% of the available height, 0 means it takes 0%. And that of course is a very helpful widget for setting different chart bar heights therefore. Besides that, I'm not doing anything fancy, just setting some colors based on my theme, though here it's worth pointing out that I'm actually dynamically deriving whether we are in dark mode or not with help of this line of code, to which I'll get back in just a second. But other than that, I just got some default styling here. And in chart dart, I'm also not doing anything fancy besides setting these chart bars. I just got more widgets to also display these icons below the chart bars. That's what I'm doing with this row, where I'm mapping all my buckets to icons, essentially, using my category icons map, which we created way earlier in this course section. This map here in expense dart in the models folder, I'm using that here to set the icons below the chart bars. And I'm also dynamically finding out whether I'm in dark mode or not here as well. So what's up with this line of code then? In Flutter, you can use the built-in media query class combined with auth context to get some information about the environment in which your app is running, so to say. And we'll see media query again in the next course section. Here we're using it to find out what the current brightness of the platform is, if it's dark or light, so if we're running in dark mode or in light mode. And I'm doing this because down here, I actually want to set different colors based on whether I am in dark or light mode. Of course, we can set up totally different colors in our themes, but here I'm actually using different colors of the generated theme color schemes, as you can see. Secondary in dark mode versus primary in light mode. And that's therefore another useful pattern to know. You're not limited to just setting some colors in your themes and then using those colors everywhere. Instead, you can set up those colors, but if you then have a case like we have it here, where in dark mode you want to use the secondary shade that was generated, whereas in light mode the primary color looks better, you can dynamically find out in which mode you're running with help of Media Query. And I'm doing this here in the chart Dart file, but also in the chart bar Dart file. Here I'm also dynamically deriving whether we're running in dark mode or not to dynamically use a different color for the color of my decorated box here, which in the end defines the color of the chart bars. And that's therefore another theme-related pattern that's worth knowing, that you can use different settings based on whether you're using dark or light mode directly in the widget tree as we're doing it here with help of Media Query. And that's also how such a chart could be rendered. You also saw this for syntax here for outputting a list of widgets, which is similar to this for syntax we used here in a non-widget place. It's almost the same, but we don't have the curly braces here. And as mentioned here, it's simply an alternative to map when using it here in a place where a list of widgets is wanted. You see the alternative down there actually. Here I am using buckets map, and we could indeed replace this with for in here as well, just as we're doing it here. But that's therefore how we can add such a chart which works in dark and in light mode, and how we can in general build such an expense tracker. And that's now it for this course section. Another long course section, but a course section with many new crucial concepts. We did, for example, learn how we can show things like a snack bar, or a modal bottom sheet, or how we can handle user input with text fields and with drop-down buttons as we're doing it here. How we can, for example, build such a manual date picker by showing a date picker with the built-in show date picker function that is provided by Flutter. We learned how we can show a dialog, and along the way we learned that this context object is important for all these methods since it carries some meta information about a widget and the widget's relation to other widgets that are required by Flutter to show all these extra elements. You learned how you can handle user input with text editing controllers, or by manually storing the input values as we're doing it here for a selected date and selected category. You learned that if you're using text editing controller, you also must dispose of it with help of the built-in dispose method into which you can hook to make sure that the memory for these controllers is freed up as they are removed. You of course also learned about many other new widgets in this course section here, like for example the icon button or app bar which we used in this app. You also practiced many of the patterns and things you learned in previous course sections, like passing pointers at functions to your own widgets, so that some child widget can call a function that belongs to a parent widget. You learned about useful widgets like the list view widget with its builder method, which is great for building lists of unknown length in a high performance way. You learned about the dismissible widget, which is great for easily making list items dismissible, as the name kind of suggests, I guess. And you of course also learned about theming, how you can define and use different color themes, how you can define different themes for light and dark mode, and how you can make sure that you're using built-in themes and you just copy them and overwrite exactly the settings you want to overwrite so that you don't have to set everything up from scratch, though you can also do that if you want to. And with that, you now of course got even more important tools in your Flutter tool belt that will help you build exactly the apps you want to build. But of course, we're also not done yet. We can and will dive in way deeper.